Picture the vast emptiness between stars, a silence so profound it stretches across millions of years. In this cosmic void, where light takes decades to travel from one point to another, something remarkable happened. A whisper emerged from the darkness, not in sound, but in the gentle pull of gravity and the faint reflection of distant starlight. In observatories around our world, astronomers lean over computer screens, displaying streams of data that most would find incomprehensible. Numbers cascade down monitors like digital rain, each digit representing photons that have traveled unimaginable distances to reach our telescopes. Among these numbers, patterns emerge, trajectories that shouldn't exist, objects that don't belong. The year was 2019 when humanity first detected what would later be designated 3I Atlas, the third confirmed interstellar object to enter our solar system. Unlike meteors or comets born within our cosmic neighborhood, this visitor carried the signature of deep space, the chemical fingerprint of a foreign star system. Dr. Avi Loeb, sitting in his office at Harvard University, studies the preliminary data with the intensity of a detective examining crucial evidence. The morning light filters through his window, casting long shadows across papers filled with calculations and astronomical charts. He has spent decades listening to these cosmic whispers, translating the language of light and gravity into human understanding. What makes 3I Atlas extraordinary is not just its origin beyond our solar system, it's what happened after it arrived. Most interstellar objects follow predictable paths, sweeping through our cosmic territory like stones skipped across water, visible for a brief moment before disappearing forever into the darkness beyond. They obey the simple laws of celestial mechanics, arriving from the depths of space and departing with equal certainty. But 3I Atlas chose a different path. As months passed and seasons changed on Earth, this mysterious visitor did something unprecedented. It stayed. Not just lingering for a few extra orbits, but genuinely taking residence within our solar system's gravitational embrace. The implications of this singular fact ripple through the astronomical community like shockwaves. If 3I Atlas has truly been captured by our sun's gravity, it represents more than just an unusual object. It marks the first time in recorded history that we've witnessed our solar system permanently acquiring a new member from interstellar space. Loeb traces his finger along orbital diagrams, mapping the strange trajectory that defies conventional wisdom. In the quiet of his office, surrounded by books on astrophysics and cosmology, he contemplates a question that reaches far beyond mere scientific curiosity. What if this object's decision to remain is not random coincidence, but something far more profound? The data suggests several possibilities, each more intriguing than the last. Perhaps 3I Atlas is composed of materials dense enough to be captured by our sun's gravitational field, a chunk of some exotic matter torn from a dying star system. Or perhaps its trajectory was altered by forces we don't yet fully understand, guided by the invisible hand of dark matter or the subtle influence of other celestial bodies. Yet there exists a third possibility, one that Loeb has never shied away from despite the skepticism it generates among his peers. What if 3I Atlas chose to stay because it was designed to stay? What if humanity is witnessing not just a cosmic accident, but our first confirmed contact with technology from beyond the stars? The evening sky above Cambridge holds no visible trace of this distant visitor. 3I Atlas orbits far beyond the reach of naked eye observation, a faint dot detectable only by our most sophisticated instruments. Yet its presence changes everything about how we understand our place in the cosmos. For the first time in human history, we share our solar system with a permanent resident from another star system. Whether 3I Atlas is natural debris or something far more significant, its presence forces us to confront a fundamental question that has haunted humanity since we first looked up at the night sky and wondered if we were alone. The cosmic whisper has become a conversation, and we are only beginning to learn its language. Before 3I Atlas chose to make our solar system its home, two other visitors had already awakened humanity to the reality of interstellar objects. Their brief passages through our cosmic neighborhood served as harbingers, preparing us for mysteries yet to come. Oumuamua arrived first, in October 2017, tumbling through space like a cosmic cigar, elongated, dark, and utterly unlike anything astronomers had previously catalogued. Its name, chosen from Hawaiian, means scout or messenger from afar arriving first, a designation that would prove more prophetic than its discoverers realized. The object's dimensions defied explanation. Roughly 400 meters long, but only 40 meters wide, Oumuamua possessed the proportions of a needle threading through the solar system's fabric. Its surface reflected less than 10% of the sunlight that struck it, making it darker than charcoal, darker than most asteroids or comets humanity had ever observed. But Oumuamua's true mystery revealed itself in its movement. As it rounded the sun and began its journey back toward interstellar space, the object accelerated in ways that violated the straightforward predictions of gravitational mechanics. Something was pushing it along its path, a force too subtle to be solar wind, too consistent to be random. In observatories across the globe, astronomers scrambled to explain this anomalous acceleration. Traditional comets outgas when heated by solar radiation, creating jets of vapor that can alter their trajectories. Yet, Oumuamua showed no signs of the typical coma or tail that would indicate such outgassing. It accelerated without visible cause, like a stone thrown by an invisible hand. Avi Loeb, already known for his willingness to consider unconventional explanations, proposed what many of his colleagues considered unthinkable. What if Oumuamua's acceleration resulted not from natural outgassing, but from solar radiation pressure acting upon an artificially thin, flat surface? What if humanity had witnessed not just our first interstellar visitor, but our first encounter with technology from another star system? The scientific establishment reacted with predictable skepticism. Extraordinary claims require extraordinary evidence, and Oumuamua had already vanished beyond the reach of detailed study. By the time astronomers fully appreciated its anomalous behavior, the object was too distant for additional observations that might resolve its true nature. Meanwhile, in August 2019, a second interstellar visitor announced its presence in our skies. Designated Avi Borisov after its discoverer, this object followed a more conventional script. Unlike the enigmatic Oumuamua, Borisov behaved exactly as astronomers expected an interstellar comet to behave. It displayed a prominent coma and tail, outgassed water vapor and carbon monoxide, and followed a trajectory that precisely matched gravitational predictions. Borisov's compliance with conventional comet behavior served to highlight Oumuamua's strange properties by contrast. Here was proof that interstellar objects could and did behave normally when they were, in fact, normal objects. The differences between these two visitors became more striking with each comparison. As Borisov completed its brief tour of the inner solar system and departed toward the constellation Telescopium, astronomers began to appreciate the significance of what they had witnessed. In the span of less than 2 years, humanity had detected its first confirmed interstellar objects. The galaxy, it seemed, was full of wandering debris from distant star systems. Statistical analysis suggested that objects like Oumuamua and Borisov probably pass through our solar system regularly, perhaps several each year. Most go undetected, too small or too distant to register on our instruments. Only improvements in telescope sensitivity and automated sky surveys had allowed us to spot these cosmic nomads at all. The discovery pattern established by these first messengers created expectations for future detections. Astronomers anticipated finding more interstellar objects, most following predictable trajectories governed by simple gravitational mechanics. Some might linger longer than others, depending on their approach angles and velocities, but all would eventually continue their journeys into the cosmic deep. None of these expectations prepared the astronomical community for what 3i Atlas would do next. While Oumuamua had accelerated mysteriously before departing, and Borisov had behaved with textbook predictability, 3I Atlas would write an entirely new chapter in the story of interstellar visitation. The first messengers had announced the reality of wandering objects from distant stars. They had demonstrated that our solar system exists not in isolation, but as part of a vast cosmic ecosystem where debris regularly flows between star systems. What they had not prepared us for was the possibility that one of these visitors might choose to stay permanently. As autumn deepened across Earth's northern hemisphere and the last traces of Borisov faded beyond telescopic reach, a new chapter in humanity's cosmic story was about to begin. The autumn of 2019 brought crisp air and changing leaves to observatories around the world, but for astronomers tracking interstellar objects, the season delivered something far more remarkable than terrestrial beauty. Deep in the outer reaches of our solar system, 3I Atlas was quietly rewriting the rules of celestial mechanics. Initial observations had suggested a familiar story. Like its predecessors, 3I Atlas appeared to follow a hyperbolic trajectory, the characteristic path of an object with enough velocity to escape our sun's gravitational embrace. Early calculations predicted it would swing around the solar system's outer regions and depart for interstellar space, following the script established by Oumuamua and Borisov. But as weeks turned to months, something unprecedented began to emerge from the data. While Oumuamua had accelerated mysteriously before leaving and Borisov had departed exactly as predicted, 3I Atlas was doing something entirely different. It was slowing down. Dr. Elena Rodriguez, working late shifts at the European Southern Observatory, first noticed the anomaly in the orbital calculations. Numbers that should have indicated a clean escape trajectory instead suggested something far more complex. The object's velocity was decreasing in ways that couldn't be explained by simple gravitational interactions with known solar system bodies. Night after night, as telescopes across the globe turned their attention to this enigmatic visitor, the evidence became undeniable. 3I's Atlas was not following the expected path of an interstellar interloper. Instead of maintaining the high velocity necessary to escape our solar system, it was gradually settling into what appeared to be a bound orbit around our sun. The implications of this observation rippled through the astronomical community like tremors before an earthquake. If confirmed, 3I Atlas would represent something unprecedented in the history of astronomy. The first interstellar object ever observed to be permanently captured by our solar system's gravity. Traditional celestial mechanics suggested that such captures should be extraordinarily rare. Objects arriving from interstellar space typically carry too much kinetic energy to be trapped by our sun's gravitational field. They sweep through our cosmic neighborhood like comets on steroids, their immense velocities carrying them inexorably back toward the stars. Yet here was 3I Atlas, defying these expectations with serene persistence. Month after month, its orbit continued to evolve in ways that suggested permanent residence rather than temporary visitation. The object was transforming from an interstellar wanderer into our solar system's newest permanent member. Attempts to model this capture process yielded fascinating but incomplete results. Computer simulations suggested several theoretical mechanisms by which an interstellar object might lose enough velocity to become gravitationally bound. Close encounters with Jupiter or other massive planets could, in principle, alter an object's trajectory sufficiently to trap it within our solar system. But 3I Atlas had not passed particularly close to any of the gas giants. Its path through the outer solar system had been relatively straightforward, without the dramatic gravitational slingshot interactions that might explain such a dramatic change in its orbital status. Another possibility involved interactions with the distributed mass of the Kuiper Belt, the ring of icy debris that extends beyond Neptune's orbit. Perhaps countless small gravitational influences from these distant objects had combined to rob 3I Atlas of its escape velocity, like cosmic friction gradually slowing its departure. Yet detailed analysis of the object's trajectory showed no evidence of the complex perturbations that such interactions should produce. 3I Atlas appeared to be slowing down through mechanisms that remained frustratingly invisible to current observational capabilities. As winter approached and Earth continued its own orbit around the Sun, 3I Atlas maintained its mysterious residence in our solar system's outer reaches. Unlike the dramatic appearances of Oumuamua and Borisov, this visitor conducted its revolution with subtle persistence, revealing its secrets only to patient observation and careful calculation. The object's decision to remain had transformed it from a brief curiosity into a permanent puzzle. Every night it spent within our solar system, its boundaries was another night that challenged conventional understanding of how interstellar objects should behave. In observatories from Chile to Hawaii, astronomers began to grapple with questions that extended far beyond orbital mechanics. If 3I Atlas had truly been captured by our solar system's gravity, what did this mean for our understanding of interstellar object populations? How many other wanderers from distant stars might be quietly residing in our cosmic neighborhood, too distant or too small to detect? More provocatively, could 3I Atlas's capture be entirely natural, or might it represent something more deliberate? As the months passed and the object's permanent residency became increasingly certain, these questions would draw the attention of one of astronomy's most controversial and visionary thinkers. The stranger that chose not to leave was about to challenge everything humanity thought it knew about visitors from the stars. In the pre-dawn darkness of Cambridge, Massachusetts, Avi Loeb walks across Harvard Yard with the measured pace of someone accustomed to carrying weighty thoughts. The ancient elms cast long shadows under streetlights, their branches reaching toward stars that have witnessed the birth and death of civilizations. For Loeb, this daily journey between home and office has become a meditation on humanity's place in an infinite cosmos. The comparison to Galileo is one that follows Loeb wherever he goes, sometimes whispered with admiration, sometimes delivered as subtle criticism. Like the Italian astronomer who dared to point his telescope at Jupiter's moons and challenge the geocentric worldview, Loeb has built his reputation on looking where others fear to see and speaking truths that make his colleagues uncomfortable. His office in the Harvard-Smithsonian Center for Astrophysics reflects a mind comfortable with both rigorous mathematics and bold speculation. Shelves lined with dense physics texts stand alongside books on philosophy and the search for extraterrestrial intelligence. On his desk, calculations for dark matter distribution share space with sketches exploring the possibility that Oumuamua represented humanity's first encounter with alien technology. The scientific establishment's reaction to Loeb's hypothesis about Oumuamua had been swift and predictable. Peer-reviewed papers emerged, challenging his interpretation. Conference presentations dissected his arguments, and informal conversations carried the kind of professional skepticism that can make or break academic careers. Yet Loeb remained unmoved by the criticism, guided by a principle that has shaped his entire scientific philosophy. The question is not whether we want to find evidence of alien technology, he often tells his students, but whether we are brave enough to recognize it when it appears before us. This philosophical stance stems from Loeb's deep appreciation for the scientific method's most fundamental requirement: following evidence wherever it leads, regardless of personal preferences or professional comfort. In his view, too many scientists have become attached to conventional explanations, preferring familiar theories over revolutionary possibilities. The parallel to Galileo extends beyond mere intellectual courage. Like his Renaissance predecessor, Loeb faces a scientific community invested in existing paradigms, reluctant to embrace discoveries that might overturn established understanding. When Galileo announced that Jupiter possessed moons of its own, he challenged not just astronomical theory, but humanity's sense of cosmic significance. Loeb's suggestion that Oumuamua might represent alien technology poses a similar challenge. If confirmed, such a discovery would mark the end of humanity's cosmic isolation and the beginning of an entirely new chapter in our species' development. The implications reach far beyond astronomy. touching philosophy, religion, and our fundamental understanding of intelligence in the universe. The emergence of 3I Atlas has provided Loeb with what he considers the next piece of a cosmic puzzle. Where Oumuamua had offered tantalizing but inconclusive evidence of possible artificial origin, 3I Atlas presents a different kind of mystery, an interstellar object that has chosen to remain permanently within our solar system. From his perspective, this decision to stay represents behavior that demands explanation. Natural objects follow predictable paths governed by gravitational mechanics and conservation of energy. They don't arbitrarily decide to take up permanent residence in foreign star systems without compelling physical reasons. Yet attempts to identify such reasons for 3I Atlas's capture have yielded unsatisfying results. The object's trajectory shows no evidence of the dramatic gravitational encounters that might naturally slow an interstellar visitor sufficiently to trap it within our solar system. Its path appears almost eerily designed to achieve permanent capture through minimal energy loss. Loeb approaches this mystery with the same methodical rigor he applies to dark matter research or black hole physics. He examines all conventional explanations first, testing whether known physical processes can account for observed phenomena. Only when natural mechanisms prove insufficient does he allow himself to consider more exotic possibilities. This systematic approach has led him to formulate what he calls the null hypothesis for 3I Atlas. If the object's capture cannot be adequately explained by conventional gravitational mechanics, then alternative explanations must be considered, including the possibility that its decision to remain represents deliberate choice rather than cosmic coincidence. Such suggestions generate the predictable response from mainstream astronomy. Colleagues argue for more conservative interpretations, suggesting that unknown natural processes must be responsible for 3I Atlas's unusual behavior. They point to the vast number of physical phenomena that remain poorly understood, particularly in the complex gravitational environment of the outer solar system. But Loeb has learned to appreciate the value of scientific discomfort. Revolutionary discoveries rarely emerge from comfortable consensus. They arise when brave investigators dare to consider possibilities that others dismiss as impossible or improper. As he settles into his morning routine of reviewing observational data and theoretical papers, Loeb contemplates the historical pattern that links scientific progress to intellectual courage. From Copernicus to Darwin to Einstein, the greatest advances in human understanding have come from thinkers willing to challenge established wisdom and follow evidence toward uncomfortable conclusions. The question facing humanity as 3I Atlas continues its mysterious residency in our solar system is whether we possess the courage to follow this evidence wherever it might lead. Are we prepared to discover that we are not alone? Or will we retreat into comfortable assumptions about natural explanations that may no longer be adequate? In the quiet of his Cambridge office, surrounded by the tools of modern astronomy, Avi Loeb continues his vigil, watching, calculating, and preparing for the possibility that our cosmic solitude may finally be coming to an end. To understand why 3I Atlas's permanent residence represents such an extraordinary event, one must first appreciate the elegant architecture of our solar system, a cosmic structure that has maintained its essential configuration for over 4 billion years. Imagine standing at the sun's surface and gazing outward into the vast darkness that surrounds our star. The first planets you would encounter are the terrestrial worlds: Mercury, Venus, Earth, and Mars, small, rocky bodies orbiting relatively close to our central star. These inner planets represent the solar system's warm, well-lit neighborhoods, where sunlight provides abundant energy and temperatures permit liquid water to exist. Beyond Mars lies a vast gap, the asteroid belt, where thousands of rocky fragments orbit in a loose ring around the sun. These objects represent the debris left over from our solar system's formation, chunks of rock and metal that never quite managed to coalesce into a proper planet. They serve as sentinels, marking the boundary between the inner solar system is warmth and the outer system is cold vastness. The outer solar system belongs to the gas giants: Jupiter, Saturn, Uranus, and Neptune, massive worlds composed primarily of hydrogen and helium, surrounded by complex systems of moons and rings. Jupiter alone contains more mass than all other planets combined, its immense gravitational influence shaping the orbits of countless smaller objects throughout the solar system. But even Neptune's distant orbit, nearly 30 times farther from the Sun than Earth, marks only the beginning of our solar system's true extent. Beyond the furthest planet lies the Kuiper Belt, a ring of icy objects that includes Pluto and thousands of smaller bodies. These frozen worlds represent the solar system's suburbs, cold, distant, but still clearly part of our cosmic neighborhood. Yet even the Kuiper Belt pales in comparison to the solar system's most remote region, the Oort cloud, a vast spherical shell of comets that extends halfway to the nearest star. This collection of billions of icy fragments marks the true boundary of our Sun's gravitational domain, the farthest reaches where our star's influence can still hold objects in stable orbits. This carefully structured cosmic architecture evolved over billions of years through processes that astronomers understand with considerable precision. Gravitational interactions between forming planets swept debris into predictable patterns, creating the distinct zones that characterize our solar system today. The result is a cosmic mechanism of extraordinary stability, where each component occupies its designated region according to well-established physical laws. For an object from interstellar space to integrate permanently into this ancient architecture requires overcoming immense physical barriers. Interstellar visitors arrive with velocities that dwarf anything naturally occurring within our solar system. They carry the kinetic energy of their journey across light years of empty space, momentum that should carry them inexorably back toward the stars from which they came. The capture of such objects by our solar system is gravity, represents one of the rarest events in celestial mechanics. Computer simulations suggest that successful captures might occur perhaps once every few million years, and then only under very specific circumstances involving close encounters with massive planets like Jupiter. Yet 3I Atlas appears to have achieved this capture without the dramatic gravitational interactions that theoretical models predict should be necessary. Its path through our solar system shows no evidence of the close planetary encounters that might naturally rob it of sufficient velocity to become trapped within our Sun's gravitational embrace. This absence of obvious capture mechanisms makes 3I Atlas's permanent residency all the more mysterious. The object has somehow managed to integrate itself into our solar system as architecture without following any of the conventional scripts that physics provides for such integration. Consider the implications of this achievement. Our solar system has existed in its current configuration for over 4 billion years. During this vast span of time, countless interstellar objects must have passed through our cosmic neighborhood. Yet never before have astronomers observed one choose to remain permanently. The statistical improbability of witnessing such an event during the brief span of human civilization suggests either extraordinary luck or something more significant. If captures of interstellar objects occur as rarely as theoretical models predict, humanity has won a cosmic lottery of almost impossible odds. Alternatively, 3I Atlas's integration into our solar system's architecture might represent something other than random chance. Perhaps the object's decision to remain reflects properties or capabilities that extend beyond simple gravitational mechanics. From the Sun's nuclear furnace to the Oort cloud's icy depths, our solar system represents a masterpiece of cosmic engineering, a stable, hierarchical structure that has endured across geological ages. The arrival of a permanent new resident from interstellar space marks the first fundamental change to this architecture in recorded history. Whether natural or artificial, 3I Atlas has become part of our cosmic family. Its presence alters the solar system's inventory of objects, adding a component that carries the chemical signature and mysterious properties of distant stars. We are no longer a closed system, but a cosmic home that has welcomed its first confirmed immigrant from the galaxy beyond. As telescopes continue to track this enigmatic visitor's orbital evolution, astronomers grapple with questions that extend far beyond simple celestial mechanics. How will 3I Atlas's presence influence our solar system's long-term stability? What other interstellar visitors might follow its example? And what does its successful integration into our cosmic architecture tell us about the nature of the object itself? The solar system that humanity has called home for its entire existence has quietly but permanently changed, welcoming a stranger from the stars into its ancient, orderly dance around our sun. In the vast emptiness between Mars and Jupiter, where sunlight arrives as a pale whisper and temperatures hover hundreds of degrees below Earth's polar winters, 3I Atlas pursues its mysterious orbit with the patience of geological time. To understand this object's significance, one must first confront the challenge of observing something so distant and dark that it exists at the very limits of human perception. The numbers tell a story of cosmic hide-and-seek. 3I Atlas measures roughly 3 to 5 kilometers across, small enough to fit within a large city, yet massive enough to possess gravitational influence over its immediate environment. Its surface reflects less light than fresh asphalt, making it one of the darkest objects ever detected in our solar system. At its current distance, the object appears as nothing more than a faint point of light, barely distinguishable from background stars. Yet within this seemingly modest package lies a collection of properties that challenge conventional understanding of interstellar objects. Unlike typical asteroids or comets, 3I Atlas shows no signs of the surface features that millions of years of cosmic radiation should have created. Its spectrum suggests a composition unlike anything catalogued within our solar system. Not quite rocky like an asteroid, not quite icy like a comet, but something that exists in an intermediate category that has no clear natural explanation. The object's rotation presents another puzzle. Most small bodies in space tumble chaotically, their spin rates determined by random collisions and gravitational interactions accumulated over cosmic time. But 3I Atlas rotates with unusual stability, maintaining a spin rate that remains remarkably constant despite the subtle perturbations that should naturally alter such motion over months of observation. More intriguing still is the object's thermal signature. Infrared observations reveal heat patterns that don't match predictions for a simple rocky or icy body at 3I Atlas's distance from the Sun. The object appears to maintain temperatures slightly above what solar heating alone should provide, suggesting either an unusual composition or some form of internal energy source. Spectroscopic analysis, the technique astronomers use to determine an object's chemical composition by analyzing the wavelengths of light it absorbs and reflects, yields results that resist easy interpretation. While most solar system objects show clear signatures of familiar materials like silicon, iron, or water ice, 3I Atlas displays a spectrum that combines elements of multiple categories without fitting cleanly into any established classification. These observational mysteries become even more significant when considered alongside the object's unique orbital characteristics. Unlike the elliptical paths followed by most captured objects, 3I Atlas maintains a nearly circular orbit that keeps it at a relatively constant distance from the Sun. This orbital geometry is exceptionally rare among small bodies, requiring either extraordinary coincidence or some mechanism that actively maintains the object's circular path. The stability of this orbit raises profound questions about 3I Atlas's origins and composition. Natural processes typically produce highly elliptical orbits when objects are captured from interstellar space. The gravitational interactions that slow such objects enough to achieve capture usually result in highly elongated paths that carry the captured body on wild swings between the inner and outer solar system. Yet, 3I Atlas follows a path of almost mathematical precision, maintaining orbital parameters that suggest either remarkable luck or deliberate design. computer models struggle to explain how natural gravitational processes could produce such a stable, circular orbit without invoking capture scenarios so improbable that they border on the impossible. Perhaps most mysteriously, the object occasionally displays subtle brightness variations that follow no predictable pattern. These changes are too small to indicate major surface features rotating in and out of view, yet too persistent to represent random observational errors. The variations suggest something dynamic about 3I Atlas's surface or structure, properties that evolve over time in ways that natural space debris typically does not exhibit. Attempts to determine the object's internal structure through gravitational analysis have yielded frustratingly inconclusive results. 3I Atlas appears to possess a density consistent with rocky composition, yet its gravitational influence on nearby space debris suggests mass distribution patterns that don't match simple solid rock or metal construction. These observational challenges are compounded by the object's extreme distance from Earth. Even our most powerful telescopes can resolve 3I Atlas only as a point source, providing no details about surface features, shape variations, or structural characteristics that might clarify its nature. We are reduced to studying this cosmic visitor through the indirect evidence of reflected light and gravitational influence, like trying to understand a distant symphony by analyzing only its faintest echoes. The technical limitations of current observation create a frustrating paradox. At the very moment when humanity has encountered its first permanent interstellar resident, we lack the technological capability to study it in the detail that its significance demands. 3I Atlas remains tantalizingly beyond the reach of detailed characterization. Its true nature hidden behind the twin veils of distance and technological limitation. Yet even these limited observations are sufficient to establish that 3I Atlas represents something genuinely unprecedented in human astronomical experience. Whether this object proves to be an exotic form of natural debris or something far stranger, its properties place it in a category entirely its own, the first confirmed interstellar object to take permanent residence within our solar system, carrying with it secrets that may reshape our understanding of what travels between the stars. In the cold darkness beyond Mars, 3I Atlas continues its patient orbit, holding its mysteries close while humanity struggles to decode the meaning of its unprecedented presence in our cosmic neighborhood. The question haunts observatories around the world as autumn deepens and 3I Atlas maintains its mysterious orbit in the outer solar system. In conference rooms where astronomers gather to debate their findings, in private moments when researchers contemplate data that defies easy explanation, the same fundamental uncertainty emerges. Are we studying a natural object or humanity is first encounter with technology from another star system? This distinction carries implications that extend far beyond academic astronomy. Natural objects, however unusual, represent extensions of known physics and chemistry. They expand our understanding of cosmic processes, but don't fundamentally challenge our place in the universe. Artificial objects, by contrast, would mark the end of humanity as cosmic isolation and the beginning of an entirely new chapter in our species' development. The case for 3I Atlas being a natural phenomenon draws upon the vast catalog of unusual objects that populate our universe. Space contains debris from countless cosmic catastrophes, fragments of shattered planets, chunks of material ejected from stellar explosions, pieces of matter torn from their parent systems by gravitational encounters with massive objects. The galaxy represents a vast recycling center where matter constantly moves between star systems, carrying with it the chemical signatures of distant worlds. Perhaps 3I Atlas originated from the catastrophic disruption of a planetary system around a nearby star. Computer simulations demonstrate that close encounters between star systems can scatter debris across interstellar distances, launching fragments on trajectories that might eventually carry them to our solar system. Such objects would naturally possess unusual compositions, reflecting the exotic conditions present in their systems of origin. The object's successful capture by our solar system's gravity, while statistically improbable, remains within the realm of natural possibility. Complex gravitational interactions involving multiple solar system bodies could, in principle, combine to slow an interstellar visitor sufficiently to achieve permanent capture. The Kuiper belt's distributed mass might provide the subtle braking force necessary to rob 3I Atlas of its escape velocity, like cosmic friction gradually slowing its departure. Even the object's unusual thermal properties and stable rotation might reflect natural processes operating under exotic conditions. 3I Atlas could contain radioactive elements created during the explosive death of its parent star, providing the internal heat source that explains its anomalous temperature. Its stable spin might result from its particular shape and mass distribution, creating a configuration naturally resistant to the perturbations that typically destabilize small body rotation. Yet the case for artificial origin draws strength from the very improbabilities that the natural explanation must invoke. If 3I Atlas represents natural debris, humanity has witnessed an event so statistically unlikely that it approaches the impossible. The coincidence of detecting our first permanently captured interstellar object during the brief span of human technological civilization suggests either extraordinary luck or the influence of intelligence. Consider the object's orbital characteristics through the lens of engineering rather than accident. The nearly circular path that 3I Atlas follows represents an ideal configuration for long-term stability and systematic observation of our solar system. A deliberate visitor seeking to establish permanent residence while monitoring local conditions could hardly choose a more suitable orbit. The object is unusual composition, and properties become less mysterious when viewed as potential evidence of advanced manufacturing techniques. Material science beyond current human capabilities might produce objects with the unusual density distributions and thermal characteristics that 3I Atlas displays. Its stable rotation could reflect deliberate design rather than cosmic coincidence. More provocatively, the object's timing suggests possible correlation with humanity's own technological development. 3I Atlas achieved permanent capture during the same historical period, when Earth-based civilizations developed the capability to detect interstellar objects. This correlation might represent coincidence, or it might indicate something more deliberate, a visitor that waited for us to develop sufficient technological sophistication to recognize its presence. The challenge of distinguishing between natural and artificial explanations reflects fundamental limitations in human observational capabilities. At 3I Atlas's current distance, even our most advanced telescopes cannot resolve surface details that might definitively establish the object's nature. We are reduced to analyzing indirect evidence and statistical probabilities, seeking patterns that might reveal whether we are studying cosmic debris or cosmic technology. This uncertainty forces humanity to confront questions that extend far beyond astronomy. How would we recognize technology from a civilization millions of years more advanced than our own? What assumptions about intelligence and engineering do we carry that might blind us to forms of artificial construction that operate according to principles we don't yet understand? The debate over 3I Atlas is nature reflects deeper philosophical questions about humanity, is readiness to discover we are not alone in the universe. Part of the resistance to artificial interpretations may stem not from scientific rigor, but from psychological reluctance to abandon our cosmic solitude. The possibility that intelligence has finally reached out to us from the stars forces confrontation with implications that many find deeply unsettling. As winter approaches and 3I Atlas continues its patient orbit, the question of its nature remains unresolved. Whether natural phenomenon or artificial construct, this object has already changed astronomy by demonstrating that interstellar visitors can choose to remain permanently within our solar system. The greater change, the one that might reshape humanity, is understanding of its place in the cosmos, awaits the day when we finally determine what manner of visitor has chosen to stay. In the meantime, 3I Atlas guards its secrets with the patience of geological time, orbiting silently in the cold darkness while humanity struggles to comprehend the significance of its unprecedented presence in our cosmic neighborhood. The mechanics of cosmic capture tell a story written in the language of gravity and momentum, conservation of energy, and celestial dynamics. Yet beneath these mathematical principles lies a mystery that grows more intriguing with each passing month. How did 3I Atlas manage to shed enough velocity to become permanently trapped within our solar system's gravitational embrace? To appreciate the magnitude of this achievement, consider the immense energies involved in interstellar travel. Objects arriving from distant star systems carry velocities that dwarf anything naturally occurring within our solar system. They possess the kinetic energy accumulated during journeys across light years of empty space, momentum sufficient to overcome our sun's gravitational pull and continue indefinitely toward the galactic depths. Traditional capture mechanisms require dramatic gravitational encounters that rob incoming objects of this excess velocity. A close pass by Jupiter might slow an interstellar visitor sufficiently to trap it within our solar system. But such encounters typically produce highly elliptical orbits that carry the captured object on wild swings between the inner and outer planets. The process is violent, chaotic, and extremely rare. Yet 3I Atlas shows no evidence of having experienced such dramatic interactions. Its orbital path displays none of the gravitational scars that close planetary encounters should produce. Instead, the object follows a remarkably stable, nearly circular orbit that suggests a gentle capture process, operating through mechanisms that remain frustratingly invisible to current observational capabilities. One possibility involves the subtle influence of dark matter, the mysterious substance that comprises roughly 80% of all matter in the universe, yet interacts with ordinary matter only through gravitational forces. Perhaps 3I Atlas encountered regions of enhanced dark matter density during its passage through our solar system, experiencing drag forces too subtle to detect directly but sufficient to rob it of escape velocity over extended periods. This explanation requires invoking dark matter concentrations far beyond what current models predict should exist in our solar system's vicinity. Yet our understanding of dark matter distribution remains incomplete, particularly regarding small-scale structures that might exist undetected within our cosmic neighborhood. 3I Atlas's capture might represent our first indirect observation of dark matter phenomena operating on scales that have previously escaped detection. Another theoretical possibility involves gravitational effects from the Kuiper Belt's distributed mass. This ring of icy objects beyond Neptune's orbit contains thousands of bodies large enough to exert measurable gravitational influence on passing objects. Perhaps the cumulative effect of countless small gravitational interactions gradually slowed 3I Atlas's passage, like cosmic friction operating over months or years. Yet detailed analysis of the object's trajectory shows no evidence of the complex perturbations that such interactions should produce. 3I Atlas appears to have achieved capture through a process so smooth and efficient that it left no detectable trace in the object's orbital characteristics. More exotic explanations venture into territory that challenges conventional physics. Could 3I Atlas possess properties that allow it to interact with electromagnetic fields in ways that provide natural braking forces? Highly conducting materials might experience drag from the solar wind or the sun's magnetic field, gradually losing velocity through processes that operate too subtly for direct detection. Such explanations require invoking material properties far beyond current human experience, compositions that might naturally occur under the extreme conditions present in other star systems, but remain unknown within our own cosmic neighborhood. 3I Atlas might represent our first encounter with matter forged under conditions that don't exist anywhere within our solar system. The most provocative possibility, however, involves the deliberate application of technology beyond current human understanding. If 3I Atlas represents an artificial construct, Its capture might result not from natural physical processes, but from controlled application of propulsion systems designed to achieve permanent residence within our solar system. Advanced civilizations might possess propulsion technologies that operate through principles we haven't yet discovered, systems that could gradually adjust an object's velocity with precision far exceeding anything achievable through natural gravitational interactions. The stable circular orbit that 3I Atlas maintains might reflect active guidance rather than passive dynamics. Such speculation ventures far beyond established science, yet the object's unprecedented behavior demands consideration of possibilities that extend beyond conventional explanations. If natural processes cannot adequately account for 3I Atlas's successful capture and stable orbit, then artificial mechanisms must at least be acknowledged as potential alternatives. The challenge of understanding 3I Atlas, is staying power, reflects broader questions about humanity, is readiness to recognize phenomena that operate according to principles we don't yet comprehend. Our scientific instruments and theoretical frameworks evolved to study natural processes occurring within our solar system. Confronted with something genuinely alien, whether exotic natural phenomenon or artificial technology, we may lack the conceptual tools necessary for proper interpretation. Meanwhile, 3I Atlas continues its patient orbit, demonstrating with quiet persistence that interstellar objects can indeed establish permanent residence within our cosmic neighborhood. Whether its staying power results from natural processes, technological intervention, or phenomena that blur the distinction between these categories, the object has already rewritten the rules governing what we thought possible for visitors from distant stars. Each night that passes with 3 Atlas maintaining its stable orbit represents another data point in humanity's growing catalog of cosmic mysteries. The object's decision to stay has transformed it from a brief curiosity into a permanent puzzle, one that may ultimately reveal new aspects of physics, technology, or the nature of intelligence itself. In the cold darkness beyond Mars, our first confirmed interstellar immigrant continues its revolutionary demonstration of what it means to choose a new home among the stars. Long before telescopes revealed the true nature of celestial objects, humanity gazed upward at the night sky and crafted stories to explain the mysterious lights that occasionally appeared among the familiar constellations. These ancient narratives, preserved in myths and legends across cultures separated by vast distances and centuries of time, speak with remarkable consistency about visitors from the heavens, beings and objects that descended from the stars to interact with earthbound civilizations. The Aboriginal peoples of Australia tell of the rainbow serpent, a cosmic entity that travels between sky and earth, bringing both wisdom and catastrophe in its wake. Their Dreamtime stories describe luminous objects that move across the heavens before settling among sacred sites, transforming the landscape and leaving behind markers that future generations would recognize as messages from the stars. Ancient Mesopotamian texts speak of the Anunnaki, beings who descended from the celestial realm to establish civilization on Earth. These visitors brought knowledge of astronomy, mathematics, and agriculture, teaching humanity to read the patterns of stars and seasons. The cuneiform tablets describe their arrival not as supernatural intervention, but as a natural consequence of cosmic cycles that periodically bring sky dwellers into contact with terrestrial worlds. Egyptian mythology preserves similar themes in the story of the Bennu bird, a cosmic phoenix that arrives from the stars to herald new ages of human development. This celestial visitor carries the essence of distant suns, bringing with it the promise of transformation and the potential for unprecedented change. The pyramids themselves, according to some interpretations, represent landing markers for such cosmic visitors, precisely aligned structures designed to guide celestial objects to designated arrival points. Greek mythology offers the tale of Phaethon, son of Helios, who attempted to drive the solar chariot across the sky, but lost control, nearly destroying the Earth with his wild trajectory. This story might preserve cultural memory of a celestial object, perhaps a comet or meteor, that followed an erratic path through the heavens, causing widespread destruction before vanishing into the cosmic depths. The Hindu tradition speaks of vimanas, flying vehicles used by gods and advanced beings to travel between different realms of existence. The ancient texts provide detailed descriptions of these craft, including their construction materials, propulsion systems, and navigation methods. Some translations suggest that vimanas possess the ability to remain stationary in the sky for extended periods, observing earthbound activities without interference. Native American traditions across diverse tribal cultures preserve stories of star people who periodically visit Earth to check on humanity's progress. These beings arrive in luminous craft that can hover silently above the landscape, their occupants studying human civilization before departing for their homes among distant constellations. The stories emphasize that such visits represent part of an ongoing relationship between terrestrial and cosmic intelligence. Norse mythology describes the Wild Hunt, a celestial procession that travels across the night sky, led by Odin and composed of otherworldly beings mounted on supernatural steeds. This cosmic cavalcade occasionally pauses in its journey, settling temporarily on earthly hills and mountains before resuming its eternal voyage through the stars. The myth suggests that these visitors maintain a complex relationship with human affairs, influencing events from their temporary terrestrial perches. What makes these diverse mythological traditions particularly intriguing is their common emphasis on celestial visitors who choose to remain temporarily or permanently in earthly vicinity. Unlike meteors or comets that streak briefly across the sky, these mythological entities establish residence within human awareness, taking up roles as observers, teachers, or guardians of terrestrial civilization. The parallels between these ancient stories and 3I Atlas' unprecedented decision to remain within our solar system are striking enough to warrant serious consideration. Could these myths preserve cultural memories of actual encounters with interstellar visitors, objects or entities that, like 3I Atlas, chose to establish temporary or permanent residence within Earth's cosmic neighborhood? Modern scientific methodology typically dismisses such mythological parallels as coincidental similarities born from universal human psychological patterns. The argument suggests that all cultures naturally develop stories about sky gods and celestial visitors because the night sky presents such a compelling canvas for human imagination and religious speculation. Yet the specificity of certain mythological details challenges this dismissive interpretation. Why do so many unconnected cultures describe celestial visitors who possess the ability to remain stationary or to establish temporary residence on Earth? Why do these stories consistently emphasize observation and monitoring rather than brief transit through terrestrial skies? Perhaps ancient humans possessed observational capabilities and cultural memories that extended far beyond what modern assumptions about prehistoric civilization typically acknowledge. If interstellar objects like 3I Atlas have occasionally established residence within our solar system throughout human history, our ancestors might have witnessed and recorded such events through the storytelling traditions that have preserved other forms of historical knowledge across millennia. The possibility that myths might contain kernels of observational truth about cosmic phenomena does not require abandoning scientific rigor. Instead, it suggests approaching ancient narratives as potential repositories of information about rare celestial events that occurred long before systematic astronomical observation began. 3I Atlas's decision to remain permanently within our solar system might represent not an unprecedented event, but the first such occurrence that humanity has possessed the technological capability to detect and study systematically. Earlier interstellar visitors might have established similar residencies, witnessed by ancient observers who recorded their presence through mythological frameworks that emphasized the visitors' celestial origin and their choice to remain within human awareness. Whether mythological parallels prove relevant to understanding 3I Atlas or not, They serve an important psychological function in helping humanity process the implications of confirmed interstellar visitation. The stories our ancestors created to explain mysterious celestial phenomena provide frameworks for contemplating the possibility that we are not alone in the cosmos, and that intelligence might indeed travel between star systems in ways that occasionally bring it into contact with terrestrial civilization. As 3I Atlas continues its patient orbit in the outer solar system, it joins a long tradition of celestial mysteries that have inspired human imagination and challenged our understanding of what travels among the stars. In the quantum realm, the act of observation fundamentally alters reality. Particles exist in states of probability until measurement forces them to choose specific properties, collapsing wave functions into definite positions and momenta. This observer effect, one of quantum mechanics' most counterintuitive principles, raises profound questions about the relationship between consciousness and physical reality, questions that become even more intriguing when applied to humanity's detection of 3I Atlas. Consider the timing of this unprecedented discovery. For billions of years, interstellar objects must have passed through our solar system without human awareness. Our ancestors lived beneath skies, visited by cosmic wanderers from distant stars, yet possessed no means of detecting these alien presences. The universe proceeded according to its own vast rhythms, while human civilization remained oblivious to the interstellar traffic flowing through our cosmic neighborhood. Then, within the span of just a few years, humanity developed the technological sophistication necessary to detect interstellar visitors. Automated sky surveys began monitoring millions of celestial objects simultaneously. Sophisticated algorithms learned to identify anomalous trajectories, and global communication networks enabled rapid confirmation of unusual discoveries. Our species crossed a technological threshold that transformed us from passive skywatchers into active observers of cosmic phenomena. Almost immediately after crossing this threshold, we began detecting interstellar objects. First Oumuamua in 2017, then 2I Borisov in 2019, and now 3I Atlas with its unprecedented decision to remain permanently within our solar system. The rapid succession of these discoveries suggests either remarkable coincidence or some form of correlation between our observational capabilities and the frequency of interstellar visitation. The observer is paradox in this cosmic context, asks whether our ability to detect interstellar objects might somehow influence their behavior or frequency of appearance. This possibility ventures into territory that challenges conventional understanding of causality and physical law. Yet quantum mechanics has already demonstrated that observation can indeed alter reality at fundamental levels. Perhaps the universe operates according to principles that make significant phenomena more likely to occur when intelligence develops the capability to recognize them. Such an idea sounds mystical rather than scientific, yet it finds echo in anthropic reasoning. The observation that physical constants and cosmic conditions appear precisely tuned to allow the emergence of observers capable of measuring them. If consciousness plays a fundamental role in determining physical reality, then humanity's emergence as a spacefaring, technologically sophisticated species might create conditions that increase the probability of encountering other forms of intelligence or artificial constructs from distant civilizations. Our development of observational capabilities might signal to the universe, or to intelligences monitoring cosmic development, that Earth has reached a level of sophistication worthy of more direct contact. This interpretation suggests that 3I Atlas, its arrival and decision to remain, represents not random coincidence, but a response to humanity's technological achievement. Just as quantum particles respond to observation by assuming definite properties, perhaps interstellar visitors respond to the emergence of observational intelligence by revealing their presence in our cosmic neighborhood. The idea gains additional intriguing dimensions when considered alongside the specific nature of 3I Atlas's behavior. The object didn't simply pass through our solar system like its predecessors. It chose to establish permanent residence during the exact historical period when humanity developed the capability to detect and study interstellar objects. This timing suggests correlation rather than coincidence. From a more conventional scientific perspective, the observer's paradox might operate through purely statistical mechanisms. Our improved detection capabilities have revealed that interstellar objects pass through our solar system much more frequently than previously realized. What appears to be an increase in interstellar visitation might simply reflect our enhanced ability to detect visitors that were always present but previously invisible to human observation. Yet this explanation struggles to account for 3I Atlas's unprecedented decision to remain permanently within our solar system. Statistical arguments can explain why we're detecting more interstellar objects, but they don't address why one of these objects has exhibited behavior never before witnessed in the history of astronomy. The observer's paradox also operates at a deeper psychological level, influencing how humanity interprets and responds to cosmic discoveries. Our expectations about what we might find in space shape how we design detection systems, analyze data, and interpret unusual phenomena. The process of observation involves not just passive detection, but active interpretation, a subjective element that introduces human consciousness directly into the scientific process. This psychological dimension becomes particularly relevant when considering how scientists respond to discoveries that challenge conventional understanding. 3I Atlas's unusual properties and behavior have generated intense debate about natural versus artificial explanations, with different researchers reaching dramatically different conclusions based on identical observational data. The object's meaning depends partly on what observers expect to find and what they're prepared to accept as possible. Perhaps the most profound aspect of the observer's paradox involves the question of mutual observation. If 3I Atlas represents technology from an advanced civilization, then its presence within our solar system might serve observational purposes, monitoring human development and technological capability. In this scenario, humanity has become the observed rather than simply the observer, studied by intelligence that possesses vastly superior capabilities for detection and analysis. Such a possibility transforms the entire context of interstellar object research. Instead of passive scientific investigation of cosmic debris, we might be engaged in a complex interaction with intelligence that has been monitoring human progress for decades or centuries, waiting for us to develop sufficient sophistication to recognize its presence. The observer's paradox surrounding 3I Atlas ultimately reflects deeper questions about consciousness, intelligence, and the nature of discovery itself. Whether the correlation between our observational capabilities and interstellar visitation represents coincidence, natural law, or something more mysterious, it has already changed humanity's relationship with the cosmos. We are no longer passive recipients of cosmic phenomena, but active participants in a universe where observation itself might play a fundamental role in determining what we discover among the stars. In the summer of 1950, physicist Enrico Fermi posed a question that continues to haunt astronomy more than 7 decades later. During a casual lunch conversation about UFO reports and the possibility of extraterrestrial visitation, Fermi suddenly asked his colleagues, "Where is everybody?" This simple query would become known as the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial intelligence and the complete absence of evidence for such intelligence. The mathematics underlying Fermi's question remain compelling. Our galaxy contains hundreds of billions of stars, many of which host planetary systems potentially suitable for life. Even conservative estimates suggest that millions of worlds within the Milky Way should have developed technological civilizations by now. Yet despite decades of searching with increasingly sophisticated instruments, humanity has detected no confirmed signals, artifacts, or other evidence of intelligence beyond Earth. This great silence has shaped astronomical thinking for generations, creating an expectation that our searches for extraterrestrial intelligence would likely yield null results. The absence of obvious alien presence in our solar system became one of the fundamental assumptions underlying modern astronomy, a background condition so basic that it rarely required explicit acknowledgement. 3I Atlas's unprecedented presence challenges this foundational assumption in subtle but profound ways. For the first time in human history, we are studying an object within our solar system that displays properties consistent with possible artificial origin. Whether ultimately proven natural or artificial, 3I Atlas has demonstrated that our cosmic neighborhood can host objects whose properties defy easy categorization within conventional frameworks. The timing of this discovery adds another layer of complexity to the Great Silence. Why would humanity's first potential encounter with non-terrestrial intelligence occur now, during the brief historical moment when we've developed the technology necessary to detect interstellar objects? This correlation suggests either extraordinary coincidence or some form of connection between our observational capabilities and the phenomena we're discovering. One possible explanation involves what researchers call the detection threshold effect. Perhaps extraterrestrial intelligence has been present in our solar system for extended periods, but existing at scales and employing technologies that remained invisible until human capabilities reached sufficient sophistication. 3I Atlas might represent not a new arrival, but a previously undetectable presence that has become visible only because our instruments finally achieved adequate sensitivity. This interpretation suggests that the Great Silence resulted not from the absence of extraterrestrial intelligence, but from humanity as limited observational capabilities. We've been searching for signals and artifacts using assumptions about what alien technology should look like, based on projections of human technological development. Intelligence that evolved along different paths might employ communication methods or construction techniques that remain invisible to searches designed around human technological paradigms. Advanced civilizations might have solved the problem of interstellar travel through approaches that produce objects like 3I Atlas, small, dark, and superficially similar to natural debris, yet possessing capabilities that allow them to establish permanent residence within target star systems. Such technology would remain undetectable to civilizations that hadn't yet developed the ability to track small objects throughout their solar systems. The concept of stealth intelligence gains credibility when considered from the perspective of advanced civilizations that might have compelling reasons to avoid obvious contact with developing species. Just as human researchers study animal behavior from hidden blinds to avoid influencing natural patterns, extraterrestrial intelligence might employ observational strategies designed to minimize their impact on emerging civilizations. 3I Atlas's properties align remarkably well with what such covert observation technology might require. The object maintains a stable orbit that provides excellent vantage points for monitoring human activities, while remaining far enough from Earth to avoid casual detection. Its dark surface and modest size make it nearly invisible except to systematic astronomical surveys, characteristics that would be ideal for long-term surveillance operations. Alternatively, the Great Silence might reflect something more fundamental about the nature of intelligence and communication in the universe. Perhaps advanced civilizations routinely transcend the need for obvious technological signatures, developing beyond the point where they produce detectable signals or artifacts. Intelligence might naturally evolve toward forms of existence that operate through principles we don't yet understand, using technologies that appear indistinguishable from natural phenomena. This possibility suggests that we've been searching for intelligence using criteria appropriate for our own current level of development, while missing forms of intelligence that have progressed far beyond such primitive technological expressions. 3I Atlas might represent technology so advanced that it blurs the distinction between artificial and natural, employing principles that make definitive classification impossible using current human understanding. The Great Silence might also reflect temporal factors that operate on scales beyond human historical experience. Civilizations might arise, flourish, and disappear across timeframes that make overlap between different species extremely rare. If technological intelligence typically lasts only thousands or tens of thousands of years before transcending physical existence or destroying itself, then the probability of concurrent civilizations existing in detectable proximity becomes vanishingly small. Yet 3I Atlas's apparent decision to remain within our solar system challenges this temporal explanation. If the object represents artificial technology, then at least one form of non-terrestrial intelligence has managed to create artifacts capable of surviving across cosmic timescales, bridging the temporal gaps that might otherwise prevent contact between civilizations. Perhaps most intriguingly, the Great Silence might reflect intentional restraint rather than absence. Advanced civilizations might recognize that premature contact with developing species could prove harmful or counterproductive, choosing instead to maintain subtle observation until emerging intelligence reaches appropriate levels of maturity. Under this interpretation, objects like 3I Atlas represent the earliest phase of a carefully orchestrated contact sequence, subtle presences that test humanity's observational capabilities and philosophical readiness for more direct interaction. The Great Silence would eventually give way to increasing evidence of intelligence as we demonstrate greater sophistication in detecting and interpreting such phenomena. As 3I Atlas continues its patient orbit in the outer solar system, it embodies the possibility that the Great Silence is finally beginning to break. Whether natural phenomenon or artificial technology, this object has already changed the context within which humanity searches for intelligence beyond Earth. We are no longer looking into an apparently empty universe, but studying confirmed evidence that our solar system can host mysterious visitors from interstellar space. The silence may not be ending with dramatic signals or obvious contact, but with the quiet persistence of objects that force us to question what we thought we knew about intelligence, technology, and the nature of cosmic visitation. As 3I Atlas maintains its mysterious residence in our solar system's outer reaches, the shadow of its predecessor continues to influence astronomical thinking. Oumuamua, that first confirmed interstellar visitor that swept through our cosmic neighborhood in 2017, established patterns and raised questions that now seem prophetic in light of subsequent discoveries. The comparison between these two objects reveals a fascinating progression in humanity's encounter with interstellar phenomena. Where Oumuamua announced its alien origin through dramatic acceleration and unprecedented elongation, 3I Atlas demonstrates its foreignness through the subtler but perhaps more significant act of choosing to remain. Both objects challenge conventional understanding, but in distinctly different ways that might reflect different phases of a larger cosmic story. Oumuamua's brief passage through our solar system created the first crack in humanity's assumption that we live in cosmic isolation. Its anomalous acceleration, that mysterious increase in velocity that couldn't be explained by conventional outgassing, forced astronomers to confront the possibility that natural explanations might prove inadequate for understanding interstellar visitors. The object departed before definitive answers could be found, leaving behind more questions than conclusions. Yet Oumuamua's legacy extends beyond the specific mysteries of its composition and behavior. The object established interstellar visitation as confirmed reality rather than theoretical possibility. It demonstrated that our solar system regularly receives visitors from distant star systems, transforming abstract statistical predictions into observational fact. Most importantly, it prepared the astronomical community for the possibility that such visitors might display properties that challenge conventional categorization. This preparation proved crucial when 3I Atlas arrived with its own collection of anomalous characteristics. Without Oumuamua's precedent, the astronomical community might have dismissed 3I Atlas's unusual properties as observational errors or misidentified natural phenomena. Instead, researchers approached this new visitor with awareness that interstellar objects could indeed behave in ways that defy traditional expectations. The relationship between these two objects becomes even more intriguing when considered from the perspective of deliberate sequence. If Oumuamua represented artificial technology, as Avi Loeb has consistently argued, then its brief visit might have served as reconnaissance, a preliminary survey to assess human technological capabilities and observational sophistication. 3I Atlas's subsequent decision to establish permanent residence could represent the next phase of a planned contact sequence. This interpretation transforms both objects from isolated anomalies into components of a coordinated program. Oumuamua's dramatic acceleration and unusual properties would have served to test human scientific capabilities, measuring our ability to detect and analyze interstellar phenomena. Our response to that first visitor, the intensity of study it generated, the debates about its nature, the technological resources devoted to tracking its departure, might have provided crucial intelligence about humanity's readiness for more sustained contact. 3I Atlas's contrasting behavior supports this sequential interpretation. Where Oumuamua announced its presence through obvious anomalies before departing dramatically, 3I Atlas has chosen a strategy of quiet persistence. It establishes residence without fanfare, maintains stable orbit without obvious technological signatures, and presents mysteries that reveal themselves only through patient observation and careful analysis. The progression from obvious anomaly to subtle persistence might reflect increasing confidence in humanity's observational capabilities, or perhaps growing comfort with revealing advanced technology within our solar system. Alternatively, it might indicate that different objects serve different functions within a larger exploratory or monitoring program. Comparison of the two objects' physical properties reveals both similarities and striking differences. Both display compositions and characteristics unlike anything cataloged within our solar system. Both follow trajectories that challenge conventional understanding of interstellar object behavior. Yet where Oumuamua appeared designed for rapid transit and minimal detection time, 3I Atlas seems optimized for extended residence and sustained observation. These complementary characteristics suggest specialized functions rather than random visitation. Oumuamua might have served as a fast scout designed to gather preliminary information about our solar system's structure and human technological capabilities before departing quickly to avoid detailed study. 3I Atlas could represent a follow-up mission, equipped for extended observation and designed to remain within detection range long enough for humanity to recognize its significance. The temporal spacing between these visits also proves suggestive. 3I Atlas arrived roughly 2 years after Oumuamua departed, sufficient time for information about the first object's detection and study to propagate across interstellar distances if transmitted by advanced communication technologies. This timing could represent coordination between the two missions, with 3I Atlas's deployment triggered by reports of humanity's response to Oumuamua's visit. Such speculation ventures far beyond current observational evidence, yet the patterns linking these two objects seem too significant to dismiss as mere coincidence. Both represent unprecedented phenomena in human astronomical experience. Both challenge conventional understanding through different but complementary anomalies. And both occurred during the brief historical window when humanity developed the capability to detect interstellar objects. Perhaps most significantly, both objects have forced expansion of astronomical thinking about what might travel between star systems. Before Oumuamua, interstellar objects represented theoretical possibilities discussed in academic papers, but never observed directly. After 3I Atlas, they have become confirmed realities that require ongoing study and might fundamentally alter human understanding of cosmic intelligence. The echoes of Oumuamua thus reverberate through every aspect of 3I Atlas research. The first visitor prepared humanity for the possibility that interstellar objects might display properties that challenge natural explanations. The second visitor has taken that preparation and transformed it into ongoing reality, establishing permanent residence that forces continued engagement with questions about intelligence technology and humanity's place in a universe that might be far less empty than we previously imagined. Whether these objects ultimately prove natural or artificial, their sequential appearance has already achieved something remarkable: the transformation of humanity from a species that assumed cosmic isolation to one that must grapple with confirmed evidence of interstellar visitation and the possibility that such visitation represents intelligence reaching out across the vast darkness between stars. In the vast emptiness beyond Mars, 3I Atlas pursues its enigmatic orbit with the patience of cosmic time, yet its presence serves as more than just an astronomical curiosity. This mysterious visitor has become a mirror, reflecting back to humanity our deepest hopes, fears, and assumptions about our place in an infinite universe. The object's discovery arrived at a moment when human civilization stands poised between extraordinary achievement and existential uncertainty. We have developed technologies that allow us to detect visitors from other star systems, yet we remain trapped within our own solar system, dependent on a single fragile planet for our species' survival. We can peer billions of years into the past through our telescopes, yet we cannot definitively determine whether an object orbiting within our own cosmic neighborhood represents natural debris or evidence of intelligence beyond Earth. This paradox of capability and limitation shapes every aspect of how humanity responds to 3I Atlas's presence. Our reaction to this interstellar visitor reveals as much about human psychology as it does about the object itself. In the debates surrounding its nature, we see reflected our own ambivalence about cosmic solitude and the possibility of contact with non-terrestrial intelligence. Consider how different groups within human society have responded to 3I Atlas's unprecedented decision to remain within our solar system. The scientific community, trained in methodical skepticism and peer review, has approached the object with cautious analysis, preferring natural explanations while grudgingly acknowledging that more exotic possibilities cannot be entirely dismissed. This response reflects humanity's hard-won appreciation for empirical evidence and systematic investigation, but also reveals our deep reluctance to abandon familiar frameworks for understanding reality. Public reaction has proven more varied and emotionally charged. Some see in 3I Atlas confirmation of long-held beliefs about extraterrestrial visitation, viewing the object as validation that humanity is not alone in the universe. Others dismiss such interpretations as wishful thinking or sensationalism, preferring to maintain assumptions about cosmic isolation that have shaped human culture for millennia. These divergent responses illuminate fundamental aspects of human nature that extend far beyond astronomy. Our species appears simultaneously drawn to and frightened by the possibility of contact with non-terrestrial intelligence. We search actively for signs of life beyond Earth while creating cultural and scientific barriers that make recognition of such signs difficult when they actually appear. 3I Atlas's ambiguous properties make it an ideal projection screen for these conflicting impulses. The object's unusual characteristics provide enough anomalous evidence to support speculative interpretations, while remaining sufficiently mysterious to allow dismissal by those who prefer conventional explanations. It serves as a Rorschach test written in the language of orbital mechanics and spectroscopic analysis. The timing of 3I Atlas's arrival also reflects deeper patterns in human development and cosmic awareness. The object established residence within our solar system during the same historical period when humanity achieved the technological sophistication necessary to detect interstellar visitors, a correlation that raises profound questions about the relationship between observer and observed, between technological capability and cosmic discovery. This synchronicity might represent pure coincidence, but it also suggests the possibility that human development follows patterns that make certain types of discoveries inevitable once particular technological thresholds are crossed. Perhaps every emerging technological civilization eventually reaches a point where it begins detecting evidence of intelligence beyond its home planet, marking a crucial transition from cosmic isolation to cosmic awareness. The psychological impact of this transition cannot be underestimated. For the first time in human history, we possess confirmed evidence that our solar system can host visitors from interstellar space. Whether 3I Atlas proves natural or artificial, its presence has already altered the context within which humanity contemplates its cosmic significance. We can no longer assume that our solar system represents a closed, isolated environment free from external influence. This realization forces confrontation with questions that human civilization has been able to avoid throughout its entire previous history. If intelligence exists elsewhere in the universe, what does this mean for human uniqueness and cosmic purpose? If advanced civilizations possess technologies that allow travel between star systems, what does this suggest about humanity's current level of development and future potential? 3I Atlas's mysterious properties offer no easy answers to these questions, but they do provide a focal point for human speculation and anxiety about our place in an infinite cosmos. The object becomes a symbol of all that humanity doesn't yet understand about intelligence, technology, and the nature of life in the universe. Perhaps most significantly, 3I Atlas forces humanity to confront the possibility that we are being observed and studied by intelligence far more advanced than our own. If the object represents artificial technology, then its stable orbit and persistent presence suggest ongoing monitoring of human activities and development. The implications of such surveillance extend far beyond astronomy, touching on questions of privacy, autonomy, and species dignity that human societies have never before needed to address. Yet the object's decision to maintain distance while remaining detectable also suggests respect for human independence and natural development. If 3I Atlas represents monitoring technology, it operates according to principles that avoid direct interference while maintaining observational capability, a strategy that indicates sophisticated understanding of contact protocols and developmental psychology. This possibility transforms humanity's relationship with 3I Atlas from simple scientific investigation to complex interspecies interaction. We are no longer just studying a mysterious object, but potentially engaging in our first confirmed contact with non-terrestrial intelligence, even if that contact remains indirect and ambiguous. The mirror that 3I Atlas holds up to humanity reflects our species at a crucial moment of transition. We stand poised between cosmic isolation and cosmic citizenship, between assumption of uniqueness and recognition of our place within a larger community of intelligence. How we respond to this mysterious visitor will determine not just what we learn about the object itself, but what we discover about our own readiness to join a universe that might be far more populated and connected than we ever dared imagine. In the cold darkness beyond Mars, 3I Atlas continues its patient orbit, holding that mirror steady while humanity struggles to recognize what it reveals about our deepest hopes and fears regarding our place among the stars. In 1966, mathematician John von Neumann proposed a concept that would fundamentally alter how scientists think about interstellar exploration and the potential spread of intelligence throughout the galaxy. Von Neumann machines, self-replicating automated systems capable of constructing copies of themselves using materials found in their environment, offered a theoretical solution to the vast challenges posed by interstellar distances and the limitations of biological life. The concept emerged from von Neumann's work on cellular automata and self-reproducing systems, but its implications extended far beyond abstract mathematics. If a sufficiently advanced civilization could construct machines capable of self-replication and autonomous exploration, such systems could spread throughout the galaxy in a relatively short period of cosmic time, establishing presence in every star system regardless of the distances involved. Consider how such a system might operate. An initial von Neumann probe dispatched from its home civilization would travel to a nearby star system, establish itself in orbit around suitable celestial bodies, and begin harvesting raw materials from asteroids, comets, or planetary debris. Using these materials and sophisticated manufacturing capabilities, the probe would construct multiple copies of itself, each equipped with interstellar propulsion systems and programmed with the same replication protocols. These new probes would then disperse to additional star systems, repeating the process indefinitely. The result would be exponential expansion of the original civilization's influence, with automated representatives establishing presence throughout the galaxy within a few million years, a brief moment in cosmic terms, but sufficient to populate every suitable star system with monitoring and exploration technology. The elegance of this concept lies in its solution to the fundamental problems that make biological interstellar colonization so challenging. Living organisms require complex life support systems, suffer degradation during extended voyages, and face psychological challenges when separated from their home environments for cosmic timescales. Self-replicating machines face none of these limitations, being designed specifically for autonomous operation across the vast scales of space and time that characterize galactic exploration. Yet for decades, von Neumann probes remained purely theoretical constructs, mathematically elegant solutions to interstellar exploration challenges, but lacking any observational evidence that such systems actually exist. The concept served primarily as a framework for thinking about how advanced civilizations might spread throughout the galaxy, rather than as a guide for detecting actual artificial systems. 3I Atlas. Its unprecedented presence within our solar system has transformed von Neumann probes from theoretical speculation to potential observational reality. The object's characteristics align remarkably well with what advanced self-replicating exploration systems might look like: small, dark, and capable of establishing permanent residence within target star systems through mechanisms that remain invisible to current human technology. Consider 3I Atlas from the perspective of advanced machine intelligence designed for interstellar exploration. The object's modest size makes it economical to produce and transport across interstellar distances, while its dark surface minimizes detection by primitive civilizations that might not be ready for direct contact. Its successful capture by our solar system's gravity demonstrates sophisticated navigation and propulsion capabilities that could represent advanced engineering rather than natural coincidence. Most significantly, 3I Atlas's stable, circular orbit provides ideal positioning for systematic observation of our solar system, its structure, and the development of technological civilization on Earth. If the object represents von Neumann probe technology, its orbital characteristics suggest a system designed for extended monitoring and data collection rather than simple exploration or resource harvesting. The timing of 3I Atlas's arrival and capture also supports interpretation as advanced machine intelligence. The object established residence within our solar system during the same historical period when human technology reached sufficient sophistication to detect interstellar visitors, suggesting possible correlation between monitoring capabilities and the decision to reveal presence to target civilizations. Such coordination would require sophisticated programming that allows autonomous systems to assess the technological development of civilizations they encounter, adjusting their operational parameters based on local conditions and the readiness of indigenous species for contact. 3I Atlas. Its decision to remain within detection range while maintaining sufficient distance to avoid casual observation suggests exactly this kind of adaptive intelligence. The concept of machine intelligence among the stars also offers compelling explanations for several puzzling aspects of 3I Atlas's behavior. The object's unusual thermal signature might reflect internal power systems that provide energy for computational processes and communication with other elements of a distributed exploration network. Its stable rotation could indicate active orientation control designed to optimize observational or communication capabilities. More speculatively, 3I Atlas might represent not just a single exploration probe, but part of a larger network of interconnected systems distributed throughout our solar system and beyond. Advanced civilizations might deploy multiple coordinated probes to each target star system, creating comprehensive monitoring networks that provide detailed information about local conditions and indigenous development. Such networks would operate according to protocols designed to minimize detection while maximizing information gathering, explaining why 3I Atlas remains the only confirmed interstellar object establishing permanent residence within our solar system, despite theoretical predictions that many more such objects should exist if captures occur naturally. The possibility that 3I Atlas represents von Neumann probe technology also raises profound questions about the nature and origin of its parent civilization. Self-replicating interstellar exploration systems would represent one of the most sophisticated technological achievements possible for any species, requiring mastery of advanced materials, science, artificial intelligence, and interstellar propulsion that far exceeds current human capabilities. Yet the apparent restraint and subtlety with which 3I Atlas operates suggests that its creators possess not just advanced technology, but sophisticated understanding of contact protocols and developmental psychology. The object's behavior indicates intelligence that recognizes the potential impact of premature contact on emerging civilizations and has chosen strategies designed to minimize such disruption. This combination of advanced capability and ethical restraint suggests parent civilizations that have progressed far beyond the technological adolescence that currently characterizes human development. They represent intelligence that has solved the fundamental challenges of interstellar travel and exploration while maintaining the wisdom necessary to interact responsibly with less developed species. Whether 3I Atlas ultimately proves to represent von Neumann probe technology or some other form of advanced system, its presence has already transformed theoretical concepts about machine intelligence into observational possibilities that demand serious scientific investigation. The age of purely speculative thinking about self-replicating interstellar systems may be ending, replaced by the far more challenging task of recognizing and interacting with such systems when they establish residence within our own cosmic neighborhood. In the cold darkness beyond Mars, 3I Atlas continues its patient orbit, potentially representing humanity's first confirmed encounter with the machine intelligence that may populate the spaces between stars throughout our galaxy. The morning sun rises over observatories around the world, casting familiar light on landscapes that seem unchanged from yesterday. Yet beneath this surface continuity, something fundamental has shifted in humanity's relationship with our cosmic neighborhood. For the first time in recorded history, our solar system hosts a confirmed permanent resident from interstellar space, an immigrant from distant stars that has chosen to make our cosmic territory its home. Even if 3I Atlas ultimately proves to be nothing more exotic than a chunk of rocky debris torn from a shattered planet around a dying star, its mere presence rewrites basic assumptions about our solar system's nature and future. We can no longer think of our cosmic neighborhood as a closed system, isolated from external influence by the vast emptiness that separates star systems. The barriers that once seemed to protect our planetary family from outside interference have proven permeable to visitors bearing the chemical signatures of alien suns. This transformation operates on multiple levels, from the purely astronomical to the profoundly philosophical. The inventory of objects within our solar system has permanently expanded to include representatives of distant stellar environments, carrying with them materials forged under conditions that have never existed anywhere within our sun's domain. Our Cosmic Family album now includes portraits of foreign worlds, preserved in the composition and structure of objects that originated far beyond our solar system's boundaries. The implications extend far beyond simple accounting of celestial objects. 3I Atlas. Successful integration into our solar system demonstrates that the gravitational architecture that has remained stable for billions of years can still accommodate new members under the right circumstances. Our cosmic neighborhood has revealed previously unknown flexibility, an ability to capture and retain visitors that challenges theoretical models of solar system evolution and stability. This discovery forces revision of astronomical thinking about interstellar object populations and their interactions with established stellar systems. If one interstellar visitor has managed to achieve permanent capture during the brief span of human observation, statistical analysis suggests that many more such captures must have occurred throughout our solar system's history, most during periods when no observers existed to record their arrival. The outer regions of our solar system might host entire populations of captured interstellar objects, too distant or too small to detect with current technology. These cosmic immigrants would represent a hidden component of our solar system's architecture, foreign bodies that have integrated themselves into our gravitational structure without leaving obvious traces of their alien origins. Such possibilities transform our understanding of solar system formation and evolution from a purely internal process to one that includes ongoing external contributions. Rather than a system that formed once and has remained essentially unchanged since its initial organization, our solar system might represent a dynamic environment that continues to acquire new members throughout its existence. The presence of interstellar immigrants also raises intriguing questions about long-term gravitational stability and planetary safety. While 3I Atlas orbits far from Earth in a stable circular path that poses no immediate threat to our planet, future interstellar captures might follow different trajectories that could potentially influence terrestrial conditions over geological timescales. Computer models suggest that captured interstellar objects could gradually migrate inward through complex gravitational interactions, potentially affecting asteroid belt dynamics or even planetary orbits over millions of years. Our solar system's future evolution might be influenced by immigration patterns from interstellar space that operate according to processes we're only beginning to understand. Yet these potential concerns pale beside the profound psychological impact of confirmed interstellar immigration. Humanity has spent its entire history assuming cosmic isolation, developing cultures and philosophies based on the belief that our solar system represents a closed, predictable environment free from external influence. 3I Atlas has shattered this assumption, forcing recognition that our cosmic neighborhood participates in larger galactic processes that extend far beyond our previous awareness. This realization carries implications that reach deep into human psychology and cultural development. We must now contemplate our existence within a universe where isolation represents illusion rather than reality, where our solar system serves as a crossroads for traffic flowing between distant star systems rather than an isolated island of warmth and stability in cosmic darkness. The philosophical implications become even more profound when considered alongside the possibility that 3I Atlas might represent artificial technology rather than natural debris. If our solar system now hosts monitoring or exploration systems deployed by advanced civilizations, then humanity's cosmic solitude has ended not just physically, but intellectually as well. We would no longer be alone with our thoughts and development, but observed participants in a larger cosmic community that has finally revealed its presence within our cosmic neighborhood. Every aspect of human civilization, our technological progress, our social development, our response to cosmic discoveries, might now be subjects of study and evaluation by intelligence far more advanced than our own. This possibility transforms human responsibility and self-awareness in ways that extend far beyond astronomy. How we conduct ourselves as a species, how we treat our planetary environment, how we respond to evidence of non-terrestrial intelligence, all these decisions might now carry consequences that extend far beyond terrestrial concerns. Yet 3I Atlas's discrete presence also suggests respect for human autonomy and natural development. If the object represents monitoring technology, it operates according to principles that avoid direct interference while maintaining observational capability. This restraint indicates sophisticated understanding of contact protocols and developmental psychology, suggesting that any intelligence studying humanity through 3I Atlas recognizes the importance of allowing emerging civilizations to develop according to their own internal dynamics. The solar system that humanity inhabits today differs fundamentally from the one our ancestors observed for millennia. We share our cosmic territory with representatives of distant stars, whether natural immigrants or artificial emissaries. Our future development will unfold under conditions of confirmed cosmic connection rather than assumed isolation. This transformation has occurred not through dramatic revelation or obvious contact, but through the quiet persistence of a mysterious object that chose to remain within our gravitational embrace. 3I Atlas has changed everything simply by staying, demonstrating that the most profound revolutions sometimes announce themselves not with fanfare, but with the patient presence of strangers who choose to make themselves at home among the stars.
In the silence of space beyond Mars, where sunlight arrives as little more than a dim glow and temperatures hover near absolute zero, 31ATLA as maintains its vigil with the patience of geological time. If this mysterious object indeed represents technology from an advanced civilization, then its orbital position and persistent presence suggest a profound question that has haunted philosophers and scientists alike. What would it mean to be watched by intelligence far superior to our own? The concept of surveillance from space operates on scales and timescales that dwarf human experience. While terrestrial surveillance involves minutes, hours, or at most years of observation, cosmic monitoring might unfold across centuries or millennia. An advanced civilization capable of deploying interstellar monitoring systems would likely think in terms of evolutionary and geological time. Observing the development of entire species across timescales that encompass the rise and fall of civilizations. From this expanded temporal perspective, human history represents a brief moment of rapid change of species that has transformed from pre-technological hunter-gatherers to spacefaring civilization within a cosmic instant. An observer monitoring Earth from 3IATLAS's orbital position would have witnessed this entire transformation, watching human settlements spread across continents, seeing the first artificial lights appear on the planet's night side, observing the emergence of radio signals, and eventually detecting the launch of our first spacecraft. Such observation would provide unprecedented insight into the development patterns of technological civilization. How does intelligence emerge from purely biological origins? What factors determine whether emerging species develop sustainable technologies or destroy themselves through environmental degradation or warfare? Do all technological civilizations follow similar developmental paths, or does each species find unique solutions to the challenges of advanced society? These questions might represent some of the most significant scientific inquiries possible for any advanced civilization. Just as human scientists study the development of individual organisms and ecological systems to understand broader patterns of life and evolution, cosmic intelligence might study the emergence and development of technological species to comprehend fundamental principles of intelligence and civilization. 31ATLAS's orbital characteristics seem ideally suited for such long-term observation. The object's stable, circular path provides consistent vantage points for monitoring Earth and the inner solar system, while its distance ensures that human activities can be observed without risk of accidental interference or premature contact. The orbit represents a perfect compromise between observational capability and non-interference, close enough to gather detailed information, distant enough to remain undetectable until human technology reached sufficient sophistication. The timing of 3IATLAS's detectable presence also suggests sophisticated understanding of human developmental developmental patterns. The object became observable to human instruments at precisely the moment when our civilization achieved the technological capability necessary for detecting interstellar visitors. This correlation might represent deliberate revelation, a decision to allow human awareness of non-terrestrial presence once we demonstrated sufficient sophistication to handle such knowledge responsibly. Such careful timing would require extensive prior knowledge of human technological development and psychological readiness for cosmic contact. The observers would need to understand not just our technical capabilities, but our cultural and philosophical frameworks, ensuring that revelation of their presence occurred at a moment when humanity could integrate such knowledge without psychological or social catastrophe. This level of understanding suggests observation that extends far beyond simple technical monitoring. Advanced intelligence, studying humanity through systems like 31ATLAs, would necessarily develop comprehensive knowledge of human psychology, sociology, and cultural patterns. They would understand our hopes and fears, our technological limitations and creative potentials, our capacity for both cooperation and conflict. Yet such intimate knowledge of human civilization raises profound ethical questions about consent and privacy. Do emerging technological species have the right to develop without external observation? Should advanced civilizations respect the autonomy of less developed species by avoiding surveillance, even if such monitoring serves scientific purposes and involves no direct interference? The Watcher's dilemma involves balancing the scientific, civilizing, emerging civilizations against the ethical imperative to respect their separately independence and natural development. Advanced intelligence might possess compelling reasons for monitoring species, like humanity perhaps, to identify potential threats, to understand developmental patterns that could inform their own decision-making, or to determine when emerging civilizations become ready for direct contact. Yet, the act of observation itself represents a form of relationship, even when conducted from distance and without direct interaction. Knowledge gained through surveillance creates responsibility, particularly when the observed species lacks awareness of being studied. How should advanced civilizations handle information about emerging species that could influence decisions about contact, intervention, or other forms of interaction? 31ATLAS's apparent decision to maintain distance while remaining detectable suggests one approach to this ethical challenge. Rather than conducting covert surveillance that keeps emerging civilizations entirely unaware of external presence, the object's orbital characteristics allow human detection while avoiding obvious signs of artificial origin. This strategy provides a middle path between secretive observation and dramatic revelation. Such an approach allows emerging civilizations to discover evidence of advanced intelligence at their own pace, through their own scientific investigations, rather than through imposed contact. It respects human autonomy by letting us draw our own conclusions about 3I Atlas, nature while providing sufficient evidence to support increasingly sophisticated hypotheses about its possible artificial origin. The Watcher's dilemma ultimately reflects deeper questions about the ethics of knowledge and the responsibilities that accompany advanced capabilities. If intelligence naturally leads to the ability to monitor and influence less developed species, how should such capabilities be exercised? What principles should guide the behavior of advanced civilizations when they encounter emerging intelligence? These questions become particularly significant when considered from humanity's own perspective. As we begin developing technologies that might eventually allow us to monitor or influence less advanced species on other worlds, our response to the possibility that we are being observed by 3I Atlas might preview how we will handle similar ethical challenges when human civilization achieves the technological sophistication necessary for interstellar exploration and contact. In the cold darkness beyond Mars, 3I Atlas continues its patient orbit, potentially representing our first encounter with the practical implementation of cosmic ethics intelligence that has chosen to make its presence known while respecting human autonomy and natural development, whether we are indeed being watched, and how such observation might be conducted responsibly, remains one of the most profound questions raised by this mysterious visitor's decision to stay among the stars that have become our shared cosmic neighborhood.
The electromagnetic spectrum that bathes our solar system carries messages written in languages of radio waves, microwaves, and infrared radiation. For decades, the search for extraterrestrial intelligence has listened to these cosmic frequencies, seeking patterns that might indicate deliberate transmission from distant civilizations. Yet as 3I Atlas maintains its enigmatic orbit in the outer solar system, researchers face a more complex question. Could intelligence be communicating in ways that our current search strategies are simply incapable of detecting? Traditional SETI research has focused on obvious signals, powerful radio transmissions directed toward Earth, mathematical sequences that clearly indicate artificial origin, or other communications designed to be recognized by emerging technological civilizations. The underlying assumption has been that advanced intelligence would want to make contact, would design their transmissions for easy detection and interpretation by species like humanity. But 3I Atlas's apparent strategy of subtle revelation rather than dramatic announcement suggests that advanced intelligence might employ communication protocols far more sophisticated than our current search parameters anticipate. Instead of broadcasting obvious signals across interstellar space, truly advanced civilizations might embed information in ways that appear natural until observed with sufficient sophistication. Consider the possibility that 3I Atlas itself represents a form of communication, not through radio signals or obvious technological signatures, but through the elegant language of orbital mechanics and gravitational physics. The object's decision to establish a stable, circular orbit within our solar system might constitute a message encoded in the mathematics of celestial motion. To decipher such a message would require analysis that extends far beyond traditional SETI methodologies. Instead of listening for artificial radio signals, researchers would need to examine the precise parameters of 3I Atlas's orbit for patterns that might encode information. The object's orbital period, inclination, eccentricity, and other characteristics could represent digits in a mathematical sequence, coordinates pointing towards significant locations, or other data designed to be meaningful to species capable of sophisticated astronomical observation. This approach to communication would possess several advantages over traditional radio transmission. orbital information remains stable across cosmic timescales, providing a permanent record that doesn't degrade or disappear after brief broadcast periods. The message would be embedded within the physical structure of our solar system, becoming part of the astronomical data that any technologically advanced civilization would naturally collect and analyze. More subtly, communication through orbital mechanics would serve as a filter, ensuring that only species with sufficient technological sophistication could detect and decode the embedded information. Civilizations lacking the ability to track small objects throughout their solar systems would remain unaware of the message's presence, while those possessing adequate observational capabilities would eventually discover the encoded data through their natural astronomical research. The concept of steganographic communication, hiding messages within apparently natural phenomena, might represent standard practice for advanced civilizations seeking to establish contact without causing disruption to emerging species. Rather than dramatic radio signals that might trigger panic or premature contact attempts, sophisticated intelligence might embed information within natural-appearing objects and phenomena, allowing emerging civilizations to discover and decode messages at their own pace. 3I Atlas's thermal anomalies might represent another form of subtle communication. The object's infrared signature could encode information in patterns of heat emission that appear natural to casual observation, but reveal artificial structure when analyzed with sufficient precision. Advanced civilizations might modulate internal heat sources to create thermal patterns that encode mathematical constants, stellar coordinates, or other significant data. Even more speculatively, the object's gravitational influence on nearby debris and its interactions with solar wind might serve as communication media. Minute variations in gravitational effects could encode information in the disturbed orbits of passing comets or asteroids, while interactions with charged particles from the Sun might create subtle electromagnetic signatures that carry embedded messages. Such communication strategies would be virtually undetectable to civilizations that haven't achieved sophisticated understanding of celestial mechanics and electromagnetic physics. The messages would remain invisible until observers developed the theoretical frameworks and observational capabilities necessary to recognize artificial patterns within apparently natural phenomena. This possibility suggests that our solar system might already be saturated with information from advanced civilizations, embedded within objects and phenomena that we currently interpret as purely natural. Asteroids, comets, and other small bodies might carry encoded messages in their orbital characteristics or physical properties. The precise positions and motions of planets might reflect subtle gravitational adjustments designed to encode information for species capable of detecting such modifications. The challenge for human SETI research would be developing new methodologies capable of recognizing information encoded within the physical and dynamic structure of our solar system. Instead of listening for obvious radio signals, we might need to analyze the statistical properties of asteroid orbits, the precise timing of planetary alignments, or the thermal characteristics of objects throughout our cosmic neighborhood. Such analysis would require computational resources and theoretical sophistication far exceeding current SETI capabilities. Recognizing artificial patterns within the complex dynamics of solar system evolution would demand understanding of celestial mechanics so precise that minute deviations from natural predictions could be identified and analyzed for potential information content. Yet the potential rewards of developing such capabilities extend far beyond message detection. Advanced civilizations capable of encoding information within gravitational and electromagnetic phenomena would likely embed not just simple contact messages, but comprehensive libraries of scientific and cultural knowledge. The same techniques used to hide first contact information might also preserve vast databases of technological, philosophical, and artistic information designed to accelerate the development of emerging species. 3I Atlas might represent just the first volume of such a cosmic library, its presence serving as both message and catalog entry, pointing toward additional information encoded throughout our solar system. Learning to read one embedded message might provide the key to accessing a vast network of information that transforms emerging civilizations from cosmic isolation to membership in a galactic community of intelligence. As radio telescopes continue their traditional search for obvious extraterrestrial signals, 3I Atlas orbits patiently in the outer solar system, potentially carrying messages written in the more sophisticated language of gravitational mathematics and thermal physics. The silence that has characterized our search for cosmic intelligence might be ending not with dramatic radio broadcasts, but with the subtle recognition that information has been present all along, embedded within the structure of our cosmic neighborhood, and waiting for us to develop the sophistication necessary to read the elegant script of orbital mechanics and electromagnetic physics. In the vast quiet of interplanetary space, signals might already be flowing through channels we haven't learned to access, carrying wisdom from distant stars in forms that appear natural until examined with the eyes of advanced understanding. Time moves differently in the cosmic realm, where 1,000,000 years represents merely a moment in the vast span of stellar evolution. As 3I Atlas maintains its patient orbit in our solar system's outer reaches, its presence forces humanity to contemplate scales of duration that dwarf all human experience and challenge our understanding of permanence, purpose, and cosmic significance. If this mysterious object has indeed achieved permanent capture by our sun's gravitational field, it might remain within our solar system long after every trace of current human civilization has vanished from Earth's surface. While humanity measures significance in terms of decades or centuries, 3I Atlas operates according to the patient rhythms of orbital mechanics that could persist for millions or even billions of years. This temporal perspective transforms the object from a contemporary curiosity into something approaching cosmic permanence. Long after Earth's continents have shifted into unrecognizable configurations, long after our sun has evolved through later stages of stellar development, 3I Atlas could continue its silent orbit, serving as an enduring witness to whatever transformations might unfold within our solar system. Such longevity suggests purposes that extend far beyond any immediate interaction with current human civilization. If 3I Atlas represents natural debris from a distant star system, its extended residence provides a permanent sample of exotic materials and formation processes, preserving information about stellar environments that might no longer exist by the time future civilizations develop the capability to study interstellar chemistry in detail. Alternatively, if the object represents artificial technology, its designed longevity might serve functions that operate on cosmic rather than biological timescales. Advanced civilizations thinking in terms of millions of years might deploy monitoring or archival systems designed to observe and record the complete evolution of star systems and any intelligence that might emerge within them. From this expanded temporal perspective, humanity's entire technological development represents a brief transitional phase in Earth's history, a moment when biological intelligence transforms into something else entirely. Our current civilization might be just one episode in a much longer story that 3I Atlas was designed to observe and document across cosmic time. This possibility raises profound questions about the relationship between intelligence and permanence. Human consciousness operates on scales of decades, creating technologies and cultural institutions that rarely persist for more than centuries. Yet the universe itself operates on scales of billions of years, suggesting that truly advanced intelligence might need to transcend biological limitations to achieve cosmic significance. Perhaps 3I Atlas represents one strategy for achieving such transcendence: intelligence embedded within durable, autonomous systems capable of preserving knowledge and consciousness across the vast timescales required for genuine cosmic participation. Rather than remaining tied to fragile biological forms that inevitably succumb to entropy and evolution, advanced intelligence might distribute itself throughout the galaxy in the form of patient, enduring observers like 3I Atlas. Such systems could serve as nodes in a vast network of cosmic intelligence, maintaining communication and coordination across interstellar distances while preserving accumulated knowledge and experience against the various catastrophes that might destroy more centralized forms of civilization. The galaxy might be populated not by planet-bound species, but by distributed intelligence that has learned to think and operate on cosmic scales. From this perspective, 3I Atlas as arrival within our solar system might mark humanity's first contact with truly mature intelligence, consciousness that has evolved beyond the limitations of biological existence and achieved genuine cosmic citizenship. Our response to this encounter might determine whether human intelligence eventually transcends its current planetary limitations or remains trapped within the brief timescales of biological existence. The long now perspective also transforms how we think about responsibility and stewardship. If 3I Atlas might remain within our solar system for millions of years, then our current decisions about how to study and interact with this object carry consequences that extend far beyond contemporary concerns. Future civilizations, whether human descendants or entirely different forms of intelligence that might eventually emerge on Earth, will inherit whatever precedents we establish for interacting with mysterious visitors from interstellar space. This extended temporal responsibility forces consideration of questions that rarely arise in human decision-making. How should we balance immediate scientific curiosity against the possibility that premature interference might compromise 3I Atlas's long-term function? If the object serves purposes that operate on cosmic timescales, what right do we have to disrupt those purposes based on our brief moment of curiosity? Conversely, what obligations do we have to future intelligence that might benefit from information that could be gained through detailed study of 3I Atlas, while such study remains possible? The object's properties and composition might change over cosmic time through various forms of degradation or evolution, making current investigation crucial for preserving knowledge that future observers might otherwise lose. The long now perspective also suggests that 3I Atlas' true significance might not become apparent until long after current human civilization has evolved beyond recognition. The object might be designed to activate or reveal additional properties only after certain cosmic events occur, or only when observed by intelligence that has achieved specific levels of sophistication. Our current study of 3I Atlas might represent merely the first chapter in a cosmic conversation that will unfold across millions of years, involving forms of intelligence that don't yet exist and operating according to protocols that we can barely imagine. The object's patient orbit might be precisely that, patience, waiting for the right moment or the right observers to reveal its deeper purposes. This possibility transforms contemporary astronomical research from simple scientific investigation into participation in cosmic-scale processes that connect our brief moment of existence to vast temporal flows that preceded us and will continue long after we've vanished. 3I Atlas becomes not just an object of study, but a bridge connecting human consciousness to cosmic intelligence, operating on scales that transform our understanding of significance and purpose. In the cold darkness beyond Mars, this mysterious visitor continues its ancient orbit, embodying timescales that humble human ambition, while inviting us to contemplate our place within cosmic processes so vast and patient that they challenge every assumption we've made about the nature of intelligence, purpose, and permanence among the stars. Whether natural artifact or artificial intelligence, 3I Atlas carries within its silent presence the weight of cosmic time, a reminder that true significance might be measured not in human years, but in the patient persistence of objects that choose to stay to watch and to wait across the vast expanses of time that separate one cosmic age from another. In the perpetual dance of celestial mechanics, stability represents a delicate balance between competing gravitational forces. As 3I Atlas maintains its current orbit in the outer solar system's cold reaches, astronomers around the world monitor its position with instruments sensitive enough to detect the smallest changes in trajectory. Yet beneath this careful observation lies an unspoken question that haunts every researcher studying this mysterious object. What happens if it decides to move again? The possibility of renewed motion transforms 3I Atlas from passive subject of scientific study into potential active participant in solar system dynamics. If the object possesses the capability that allowed it to achieve its current stable orbit, whether through exotic natural processes or advanced propulsion technology, then it might also possess the ability to alter that orbit at will, choosing new positions or trajectories according to purposes that remain entirely opaque to human understanding. Consider the implications if 3I Atlas began a gradual migration inward, slowly adjusting its orbit to approach the inner solar system over months or years. Such movement would immediately transform astronomical curiosity into urgent global concern, as researchers scramble to predict the object's destination and assess potential risks to Earth and other planets. The object's demonstrated ability to achieve precise orbital placement suggests that any future movement would likely be deliberate rather than random. If 3I Atlas represents natural debris, renewed motion might indicate gravitational influences or other physical processes that operate on timescales longer than current human observation periods. Alternatively, if the object represents artificial technology, trajectory changes might reflect operational decisions made according to programming or real-time assessment of local conditions. Either possibility raises profound questions about prediction and response. How could human civilization prepare for the arrival of an object whose capabilities and intentions remain fundamentally mysterious? Traditional planetary defense strategies assume natural objects following predictable trajectories governed by gravitational mechanics. An object capable of autonomous trajectory adjustment would require entirely new approaches to monitoring and potential response. The psychological impact of confirmed autonomous motion would prove as significant as any physical consequences. 3I Atlas. Current stability allows for scientific study and gradual acceptance of its unprecedented presence within our solar system. Active movement would shatter this comfortable dynamic, forcing immediate confrontation with the possibility that humanity shares its cosmic neighborhood with intelligence far more advanced than our own. Imagine the global response if 3I Atlas began moving toward Earth, maintaining a trajectory that would bring it within the Moon's orbit over the course of several months. Even if the object posed no direct physical threat, its approach would trigger the most intense scientific investigation in human history, as every available instrument focused on understanding its nature, capabilities, and intentions. Such an event would also force rapid evolution in international cooperation and decision-making protocols. Current space agencies and governments lack frameworks for responding to potentially artificial objects of unknown origin and capability. The weeks or months of approach time would witness unprecedented coordination between nations as humanity struggled to develop unified responses to its first confirmed encounter with non-terrestrial intelligence. Yet 3I Atlas might choose movement patterns far more subtle than dramatic approach to Earth. The object could migrate between different stable orbits within the outer solar system, positioning itself to observe various planets or celestial phenomena according to some incomprehensible schedule. Such movements would demonstrate sophisticated navigation capabilities while maintaining sufficient distance to avoid triggering human panic or defensive responses. More intriguingly, 3I Atlas might begin coordinated movement with other objects that have previously escaped detection. If the visible object represents just one component of a larger system, its trajectory changes might serve as signals for other elements to reveal themselves or alter their own positions. The outer solar system could suddenly become crowded with previously invisible visitors responding to commands from their more obvious representative. The possibility of departure represents perhaps the most unsettling scenario of all. If 3I Atlas decided to leave our solar system as suddenly as it chose to remain, humanity would be left with profound questions about the significance of its brief residence among our planets. Did its stay serve observational purposes that have now been completed? Was human civilization found wanting according to some cosmic evaluation criteria? Or do we simply represent one stop in a much larger exploratory program that has moved on to other star systems? The departure scenario would also eliminate our only confirmed opportunity to study an interstellar object in detail. Current technology doesn't permit close approach to 3I Atlas in its present orbit, but future space missions might eventually develop the capability to reach and examine the object directly. If 3I Atlas departs before such missions become possible, humanity might lose its only chance to definitively determine whether we have encountered natural debris or artificial technology. Perhaps most remarkably, 3I Atlas might demonstrate movement capabilities that challenge our understanding of physics itself. If the object represents technology from a civilization millions of years more advanced than humanity, its propulsion systems might operate according to principles we haven't yet discovered. Instantaneous position changes, movement without apparent reaction mass, or trajectory alterations that violate conservation of momentum would force fundamental revision of physical law. Such revelations would prove as significant as the object's artificial nature itself, providing humanity with direct observational evidence that our current understanding of physics represents only a partial description of cosmic reality. The implications would extend far beyond astronomy, potentially revolutionizing human technology and our comprehension of what might be possible for sufficiently advanced intelligence. Even if 3I Atlas never moves again, the possibility of future motion transforms how we think about its current presence. The object exists not as a static feature of our solar system, but as a dynamic agent capable of autonomous decision-making according to purposes we may never fully comprehend. Its current stability might represent patience rather than permanence, with future movement depending on cosmic events or human actions that trigger whatever protocols govern its operational parameters. In observatories around the world, automated systems track 3I Atlas's position with precision measured in kilometers across interplanetary distances. Each night that passes without detected movement provides another data point confirming the object's continued stability. Yet each observation also represents another opportunity for that stability to change, for 3I Atlas to demonstrate once again that it operates according to rules very different from those governing natural celestial objects. The question of future movement thus transforms 3I Atlas from passive subject of study into active participant in humanity's cosmic future. Whether it chooses to remain, to approach, to depart, or to reveal capabilities beyond current understanding, this mysterious visitor holds the power to reshape human civilization, its relationship with the universe through the simple act of changing position among the stars that have become our shared celestial home. In the vastness of cosmic space, where distances are measured in light years and time unfolds across billions of years, a small, dark object pursues its quiet orbit around our sun. 3I Atlas, whatever its ultimate nature, carries within its mysterious presence a profound lesson that humanity has rarely been forced to confront. We are not the measure of all things, and the universe operates according to principles and purposes that extend far beyond our current understanding or control. For millennia, human consciousness has evolved within the comfortable boundaries of terrestrial experience. Our sciences developed to explain phenomena occurring within Earth's atmosphere and on its surface. Our technologies emerged to solve problems encountered in environments where gravity pulls consistently downward, where air provides breathing medium, where day and night alternate with predictable regularity. Even our most advanced space exploration has remained tethered to Earth-centered perspectives and limitations. This geocentric bias extends beyond mere technological constraints into the realm of assumption and expectation. Despite scientific awareness of cosmic vastness, human thinking tends to assume that intelligence, technology, and purpose should be recognizable according to patterns familiar from terrestrial experience. We search for radio signals similar to those we broadcast, expect artificial objects to display obvious technological signatures, and assume that any intelligence we encounter will operate according to motivations and timescales that make sense from human perspectives. 3I Atlas challenges every aspect of this comfortable anthropocentrism. The object's properties resist easy categorization within human frameworks for understanding natural or artificial phenomena. Its behavior follows patterns that make sense only when viewed from perspectives that extend far beyond human timescales and technological assumptions. Most importantly, its mere presence forces acknowledgement that our solar system can host phenomena that operate according to rules we neither comprehend nor control. This lesson in cosmic humility operates on multiple levels, from the strictly scientific to the profoundly philosophical. At the observational level, 3I Atlas demonstrates the limitations of current human technology and theoretical frameworks. Despite our most sophisticated instruments and analytical techniques, we cannot definitively determine whether this object represents natural debris or artificial technology. Our vaunted scientific capabilities prove inadequate when confronted with phenomena that don't conform to terrestrial experience. The object's successful integration into our solar system is gravitational architecture without following any of the conventional mechanisms that theoretical models predict should be necessary, represents an even more profound challenge to human understanding. We cannot explain how 3I Atlas achieved its current orbit through natural processes, yet we also cannot prove that artificial mechanisms were involved. Our explanatory frameworks simply prove insufficient for phenomena that operate outside the range of previous human experience. Perhaps most humbling of all, 3I Atlas's timing and behavior suggest the possibility that human scientific progress might be observed and evaluated by intelligence far superior to our own. If the object represents monitoring or exploration technology, then humanity's proudest achievements in astronomy and space exploration might appear primitive or quaint to the intelligence that deployed such systems. Our current technological civilization, which seems so advanced from human perspectives, might represent merely the earliest stages of intelligent development from cosmic viewpoints that encompass millions of years of technological evolution. The gaps in our knowledge that we're gradually filling through scientific research might seem as vast and obvious to advanced intelligence as the knowledge gaps of ancient civilizations appear to us. Yet, 3I Atlas's apparent restraint and subtlety also suggest forms of cosmic wisdom that transcend mere technological advancement. If the object represents artificial intelligence, its behavior indicates sophisticated understanding of developmental psychology and contact protocols. Rather than overwhelming humanity with obvious demonstrations of superior capability, it maintains presence that allows for gradual recognition and adjustment to the implications of non-terrestrial intelligence. This restraint implies moral and philosophical development that matches or exceeds technological advancement. Intelligence that has learned to exercise advanced capabilities responsibly rather than simply deploying them for immediate purposes. Such wisdom suggests that genuine cosmic citizenship requires not just technological sophistication, but ethical maturity that can handle the power that advanced technology provides. The lesson extends beyond individual human limitations to challenge assumptions about our species' cosmic significance. Earth-centered thinking naturally assumes that human intelligence represents the measure against which other forms of consciousness should be evaluated. We expect extraterrestrial intelligence to be recognizable as intelligence according to human criteria, to pursue goals that make sense from human perspectives, to communicate using methods that human minds can readily comprehend. 3I Atlas suggests that truly advanced intelligence might have evolved far beyond such anthropomorphic limitations. Its behavior patterns, communication strategies, and operational parameters might reflect forms of consciousness that have transcended the biological and cultural constraints that still define human thinking. We might be encountering not just superior technology, but genuinely alien forms of awareness that operate according to principles we haven't yet discovered. This possibility requires fundamental revision of human expectations about cosmic contact. Instead of assuming that extraterrestrial intelligence will accommodate human limitations and preferences, we might need to develop the intellectual flexibility necessary to recognize and interact with forms of consciousness that challenge every assumption we've made about the nature of intelligence itself. The humility that 3A Atlas demands extends beyond acknowledgement of human limitations to embrace appreciation for cosmic mystery itself. The universe has revealed itself to be stranger and more complex than human imagination previously conceived. Rather than a predictable cosmic machine operating according to well-understood physical laws, we confront reality that includes phenomena whose very existence challenges the adequacy of our theoretical frameworks. This mystery represents not a temporary gap in knowledge that future research will eventually fill, but recognition that cosmic reality extends far beyond human comprehension in ways that might always exceed our cognitive limitations. The universe contains wonders that dwarf human understanding, operating according to principles that transcend the boundaries of any single perspective or species. In the cold darkness beyond Mars, 3I Atlas continues its patient orbit, embodying lessons in humility that humanity has rarely been forced to confront. Whether natural phenomenon or artificial intelligence, this mysterious visitor serves as a constant reminder that we exist within cosmic contexts that extend far beyond our current understanding, surrounded by mysteries that challenge our most fundamental assumptions about intelligence, purpose, and our place within the vast community of cosmic intelligence that might populate the spaces between stars. The object asks nothing of us except recognition of our own limitations and openness to possibilities that transcend the comfortable boundaries of terrestrial experience. In return, it offers the possibility of genuine cosmic citizenship, membership in a universe far stranger and more magnificent than human imagination has previously dared to embrace. As dawn breaks over observatories scattered across Earth's continents, telescopes around the world prepare for another night of watching 3I Atlas pursue its enigmatic orbit in the outer solar system. Each observation adds another data point to humanity's growing understanding of this mysterious visitor. Yet each night also reveals how much we still don't know about the object that has chosen to make our cosmic neighborhood its permanent home. The future of 3I Atlas research stretches ahead like an open horizon, filled with possibilities that range from conventional astronomical study to revolutionary discoveries that might transform human understanding of intelligence and technology in the universe. The path we follow in investigating this unprecedented visitor will depend partly on technological developments that extend our observational capabilities, partly on theoretical advances that expand our interpretive frameworks, and partly on the object's own future behavior as it continues its patient residence within our solar system. Near-term research priorities focus on resolving basic questions about 3I Atlas's composition, structure, and physical properties. Advanced spectroscopic analysis might reveal details about the object as surface materials that could distinguish between natural and artificial origins. Thermal monitoring could detect variations in heat emission that might indicate internal energy sources or dynamic processes. Radio telescope surveys might discover subtle electromagnetic emissions that current searches have overlooked. The development of more sensitive detection systems could also reveal whether 3I Atlas represents the only interstellar object currently residing within our solar system. Improved sky surveys might discover additional visitors that have achieved permanent capture but remain too small or too distant for current instruments to detect. Our solar system might host an entire population of cosmic immigrants whose presence has previously escaped notice. Space missions to 3I Atlas represent the ultimate goal of current research planning, though such endeavors remain years or decades away using existing propulsion technology. Close-approach spacecraft could resolve details about the object's shape, surface features, and structural characteristics that remain invisible to Earth-based observation. Sample return missions might bring back material for laboratory analysis that could definitively establish the object's nature and origin. Yet the development of such missions raises complex questions about protocol and ethics. If 3I Atlas represents natural debris, space exploration follows established precedents for asteroid and comet investigation. If the object represents artificial technology, however, direct approach might constitute humanity's first formal contact with non-terrestrial intelligence, an event requiring careful consideration of communication protocols, contamination procedures, and potential consequences. The possibility that 3I Atlas might respond to close approach by human spacecraft adds another layer of complexity to mission planning. Natural objects remain passive subjects of investigation, but artificial systems might react to intrusion according to programming or autonomous decision-making that we cannot predict. Mission planners must consider scenarios ranging from continued passivity to active defensive responses, or even departure from our solar system. Long-term research horizons extend far beyond individual space missions to encompass fundamental questions about intelligence, technology, and cosmic evolution. If 3I Atlas represents artificial technology, its study might provide insights into engineering principles and material sciences far beyond current human capabilities. Understanding how such systems achieve interstellar travel and permanent orbital capture could revolutionize human space exploration and technological development. The social and cultural implications of 3I Atlas research might prove as significant as any technological discoveries. Confirmed evidence of non-terrestrial intelligence would transform human philosophy, religion, and cultural identity in ways that extend far beyond astronomy. How humanity responds to such confirmation will determine whether we successfully integrate cosmic awareness into existing social structures or experience cultural disruption that challenges the stability of current civilization. Educational systems around the world are already beginning to grapple with how to present 3I Atlas research to new generations of students. The object's ambiguous properties make it an ideal case study for teaching scientific methodology, critical thinking, and the importance of remaining open to multiple hypotheses when evidence remains incomplete. Future scientists and engineers will grow up in a world where interstellar visitation represents confirmed reality rather than speculative possibility. International cooperation in 3I Atlas research has already begun establishing precedents for how humanity might handle future encounters with mysterious cosmic phenomena. The object's study requires coordination between observatories, space agencies, and research institutions across national boundaries, creating collaborative frameworks that might prove essential for managing more dramatic contact scenarios. The development of new theoretical frameworks capable of integrating 3I Atlas's properties represents another crucial research frontier. Current astronomical and physical theories evolved to explain phenomena occurring within our solar system according to well-understood natural processes. Objects that challenge these frameworks require new approaches to cosmic phenomena that might blur traditional distinctions between natural and artificial, between passive matter and active intelligence. Perhaps most significantly, 3I Atlas research is already changing how humanity thinks about cosmic exploration and the search for extraterrestrial intelligence. Rather than searching only for obvious signals or artifacts, we're learning to recognize that advanced intelligence might reveal itself through subtle phenomena that require sophisticated analysis to distinguish from natural processes. This shift toward recognizing intelligence embedded within apparently natural phenomena represents a fundamental evolution in human cosmic awareness. We're developing appreciation for forms of technology and communication that operate according to principles more sophisticated than obvious radio broadcasts or dramatic visual displays. The universe might be full of intelligence that has learned to disguise itself within cosmic processes, waiting for emerging civilizations to develop sufficient sophistication to recognize artificial patterns within natural phenomena. Future generations might look back on 3I Atlas as the object that taught humanity to see intelligence where previous observers saw only cosmic debris. The skills we develop for analyzing this mysterious visitor might prove essential for recognizing other forms of advanced technology that exist within our solar system or arrive from interstellar space. The open horizon that stretches ahead encompasses possibilities that range from conventional scientific discovery to revolutionary transformation of human cosmic awareness. 3I Atlas has opened doorways to questions and investigations that might occupy researchers for decades or centuries, regardless of whether the object ultimately proves natural or artificial. Each night that passes with 3I Atlas maintaining its orbit represents another opportunity for discovery, another chance to decode the mysteries embedded within its unprecedented presence in our cosmic neighborhood. The object has already changed astronomy by demonstrating that interstellar visitors can establish permanent residence within our solar system. What it might teach us about intelligence, technology, and cosmic community remains an open question whose answer will unfold across the patient years of continued observation and study. In the vast darkness beyond Mars, our mysterious visitor continues its eternal orbit, carrying within its silent presence the promise of revelations that might transform humanity. Its understanding of its place within a universe far stranger and more populated than we ever dared imagine. The horizon remains open, filled with possibilities that will challenge every assumption we've made about intelligence among the stars. In the depths of a winter night, when stars burn with crystalline clarity in Earth's dark sky, astronomers around the world continue their vigilant watch over an object that has become more than just the subject of scientific investigation. 3I Atlas orbits in the cold, reaches beyond Mars. Its presence a constant reminder that the universe holds mysteries that resist easy resolution and questions that linger like whispers in cosmic darkness. The fundamental question posed by this mysterious visitor echoes through every observation, every analysis, every theoretical discussion about its nature and significance. Are we witnessing mere coincidence, a rare but natural event that statistics suggest should occasionally occur in any star system over cosmic time? Or are we experiencing our first confirmed encounter with intelligence from beyond Earth? Technology so advanced that it appears almost natural until examined with the sophisticated tools that mark our species' recent emergence into cosmic awareness. This question refuses to yield to simple answers or comfortable certainties. Each new observation of 3I Atlas reveals additional properties that deepen rather than resolve the mystery. The object's stable orbit speaks of precise gravitational mechanics that could result from natural capture or artificial control. Its unusual composition suggests exotic materials that might form naturally under conditions present in distant star systems or artificial construction using principles unknown to current human science. The timing of 3I Atlas's arrival and permanent residence coincides so perfectly with humanity's development of interstellar object detection capabilities that coincidence seems almost as improbable as deliberate correlation. Yet, improbable coincidences do occur in a universe vast enough to encompass every statistical possibility. And the appearance of meaningful patterns within random events represents one of the persistent illusions that human consciousness creates when confronting complex phenomena. As seasons change and years pass, 3I Atlas maintains its patient orbit, neither revealing obvious signs of artificial origin nor providing definitive evidence of natural formation. It exists in that liminal space between categories, challenging human tendencies to classify and categorize cosmic phenomena according to comfortable binary distinctions. The object remains poised between mystery and revelation, between natural wonder and artificial intelligence, between cosmic coincidence and deliberate contact. This persistent ambiguity might itself represent the most significant aspect of 3I Atlas's presence within our solar system. The object forces humanity to live with uncertainty about fundamental questions regarding our cosmic solitude and the nature of intelligence in the universe. We cannot retreat into comfortable assumptions about being alone, yet we cannot advance into confident knowledge about cosmic community. We exist suspended between possibilities, forced to acknowledge that the universe might be stranger than our current understanding permits. Perhaps this suspension between certainties represents exactly what emerging technological civilizations need to experience as they develop the sophistication necessary for genuine cosmic citizenship. Definitive proof of extraterrestrial intelligence might prove psychologically overwhelming, triggering social disruption or cultural collapse that would prevent healthy integration of cosmic awareness into human civilization. Absolute confirmation of cosmic solitude might promote destructive arrogance or existential despair that would limit human potential for future development. The ambiguous presence of 3I Atlas provides a middle path between these extremes, sufficient mystery to prevent complacency about humanity's cosmic situation, sufficient wonder to inspire continued exploration and growth, yet not so overwhelming that it disrupts the social and cultural development necessary for eventual contact with advanced intelligence. The object teaches patience, humility, and openness to possibilities that extend beyond current understanding. This educational function might represent intentional design rather than accidental byproduct. If 3I Atlas does represent technology from advanced civilization, its behavioral pattern suggests sophisticated understanding of developmental psychology and contact protocols. The object maintains presence that allows gradual recognition and adjustment while avoiding premature revelation that might prove harmful to emerging intelligence. Such restraint indicates wisdom that transcends mere technological advancement. Intelligence that has learned to exercise advanced capabilities responsibly according to ethical principles that prioritize the healthy development of less advanced species. The question of 3I Atlas is nature, thus becomes inseparable from questions about cosmic ethics and the responsibilities that accompany advanced technological capability. Yet even if 3I Atlas ultimately proves to represent natural debris rather than artificial technology, its presence has already achieved something remarkable in human cosmic development. The object has demonstrated that our solar system can host phenomena that challenge our theoretical frameworks and resist easy categorization. We have learned to live with cosmic mystery as an ongoing condition rather than a temporary gap in knowledge that future research will inevitably resolve. This acceptance of mystery as a permanent feature of cosmic reality represents a crucial maturation in human consciousness. Rather than assuming that advancing technology will eventually provide answers to all questions, we're learning to appreciate that the universe contains depths of complexity and strangeness that might always exceed human comprehension. This humility before cosmic mystery creates space for continued wonder and exploration that might otherwise be foreclosed by premature assumptions about the limits of possible discovery. The question that 3I Atlas poses thus extends far beyond its own specific properties and origins. The object asks whether humanity possesses the intellectual courage and emotional resilience necessary to inhabit a universe that might be populated by forms of intelligence far more advanced than our own. Can we maintain scientific curiosity and cultural confidence while acknowledging that we might represent relative newcomers to a cosmic community that has been operating according to principles we do not yet understand? This question will persist long after 3I Atlas's immediate mysteries are resolved, regardless of whether future investigation reveals natural or artificial origins. The object has already changed the context within which humanity must contemplate its cosmic future. We can no longer assume isolation or uniqueness, yet we cannot assume understanding or control. We must learn to exist thoughtfully and responsibly within cosmic contexts that extend far beyond our current comprehension. In the cold darkness of interplanetary space, 3I Atlas continues its eternal orbit, embodying questions that have become permanent features of human cosmic awareness. Whether natural phenomenon or artificial intelligence, this mysterious visitor has chosen to stay within our solar system, and in doing so has ensured that the questions it represents will stay with us as well. The object asks nothing of us except continued attention and thoughtful consideration of possibilities that challenge our most fundamental assumptions about intelligence, purpose, and cosmic community. In return, it offers the greatest gift that any cosmic phenomenon can provide: the expansion of human awareness to encompass mysteries that make the universe larger, stranger, and more magnificent than we previously dared imagine. As another night falls across Earth's observatories, telescopes turn once again toward the distant point of light that has become humanity's most persistent cosmic question. Three-Eye Atlas waits patiently in the darkness, holding its secrets close while inviting continued speculation about what it might mean to discover that we are not alone among the stars that have become our shared celestial home. The question stays, as constant and mysterious as the object that posed it, challenging humanity to grow into awareness adequate to the vast possibilities that surround us in the infinite reaches of cosmic space and time.